Hello everyone, welcome to today's video on Pyspark at Intellipaat. Do you know friends that today every organization wants to analyze its data for making its sales better. The patterns revealed by data can have a significant impact on marketing strategies and the quality of product or service offered by the company. And to achieve the same, engineers use Spark with Pyspark. Pyspark is being adopted by a lot of businesses pretty quickly, and the job opportunities for Pyspark are growing daily at an exponential pace. The Pyspark service market is predicted to grow at a compound annual growth rate of 36.9% from 2019 to 2026, reaching $61.42 billion. As a result, the need for big data engineers and specialists is expected to increase in the future years. The average income for a Spark developer in India is more than 7,50,000 rupees per year according to the pay scale. The annual pay includes bonuses offered by the firm. Now before we head on to the technical jargon for Pyspark, do not forget to hit that subscribe button and click on the bell icon for our Intellipaat YouTube channel so that you never miss any update coming from our team. We'll begin this session on a very friendly note by talking about what is Pyspark. Next, we'll cover Pyspark Module Functions, operations on RDDs, introduction to raw layer, goal layer and reporting layer, as well as introduction to Spark SQL. After that, we'll discuss Spark DataFrame API, Spark DataFrame transformations, loading data through different sources, etc. Then finally, we'll jump onto what is needed for Kafka, the components of Kafka, and the Kafka Flume integration. I hope I have made myself clear with the agenda. So let's dive into the session directly.
Pyspark is an open source framework that uses the Apache Spark processing engine to do distributed processing on huge datasets. This was just an introduction to Pyspark. We will explore the term in more detail. Let's begin then. Well, now we all know Python is a buzzword in the world of languages. Pyspark offers Python interface for programming Spark. It allows developers to construct Spark applications in the popular Python programming language, which has a strong developer community. Pyspark also includes various high-level Spark APIs such as Spark SQL, Spark Streaming, mlib, and GraphX. These APIs make it easy to build complex data processing pipelines, machine learning models, and graph computations. The question is, where did Pyspark come from? Pyspark was initially presented as a part of the Apache Spark project in 2012. The AMP lab at UC Berkeley created Apache Spark, which was first published in 2010 as an open source large data processing engine. Spark previously had only APIs for Java, Scala, and R. Eventually, Pyspark was added to the project to give a simple Python API for Spark. Being one of the most popular frameworks, Pyspark has gained immense popularity. A career in Pyspark can be very rewarding. You can go for making a career as a Pyspark developer. Curious to know about who a Pyspark developer is? A Pyspark developer is a software developer that specializes in creating apps that handle and analyze massive datasets using the Pyspark framework. A Pyspark developer's average annual salary in India ranges from 8 to 10 lakhs for entry-level roles and 20 to 25 lakhs for experienced professionals. And in the United States, it ranges between $100,000 to $150,000 depending on the experience and the location.
Yeah, so we have seen map partitions and everything. So now we will see the next function, which is group by. Okay, so what does group by do? So group by, just like in SQL, how data gets grouped together based on a particular column, same thing exists here as well. Only thing is, instead of column, it will be the function. Based on the function output, whatever is the function output, we will group the entire RDD. For example, here it is saying that for each row, if each row is divisible, whatever is the reminder, when you divide the row value with 2, right? So let's say, for example, 1 divided by 2, the remainder is 1, right? So that would be acting as the key on which you would group the set, right? So all the rows where the remainder will be 1, this is also 1, this is also 1, and this is also 1. So all these will be grouped together. All those which had remainder 0, which is this, will be grouped together, right? So that will be based on the outcome of the particular function in the group by, right? So for example, I want to group by, let's go with the cricket data itself. I want to see. Remove these functions, put it somewhere else. And I will remove this. Bring back the old one. So I'm removing the header here. I'm removing all the rows with okay. And sort by, get the top 10. Yeah, already do. 0 player. Okay. Partition information. Based on the partition, I'm gonna get it. Okay, fine. Whatever is, I don't even need this actually, to be honest. Fine, we did that. Let me see. This index is out of range. Into 0, 1, 2, 3, 4, 5, 6, 7, 10, 16, 17. 17 is there, but I am asking for 18. Okay. Must have. Yeah, here I've added the index number. Okay, fine. I don't need it. We'll just do this. No. 0, 1, 2, 3, 4, 5, 6, 11, 13, 14, 15, 16, 17. Okay. So let's say my boss comes and says, okay, fine, we'll group all players who have played for the same country together. Okay. So in that case, I have a 17th element in each row, which is giving the country, because I've already calculated the country in the first step using the map function.
Let's have a quick quiz question, guys, and the question is, in Pyspark, dash library is provided which makes integrating Python with Apache Spark easy, and your options are Py5j, Py4j, Py3j, or none of the above. Please mention your answers in the comment section below.
Convert string row to list. So here we calculate the country. Okay. So once that is done, we have a 17th element, that is the country, right? So now let me take grouped RDD where RDD, I don't want to take top 10. Okay. RDD top 10. By lambda row 17. Okay. So whatever is the output of the value of the 17th element, 18th element of the row, all those rows having the same values will be grouped together, right? So if someone who has played for India will have the country India, he'll be grouped together. Rohit Sharma, Virat Kohli, everybody will be grouped together. Pakistani players will be grouped together. New Zealand players will be grouped together, and so on and so forth. Only difference is now we cannot see a grouped RDD. If I do a print, you will see that it will come as an iterable. Okay. It will only print the key. Key is what? The output of row 17. I mean, the 17th element is in each row will be the key. Correct? So you can only see the key. Rest all it will be an iterable. So if you see here, iterable. Okay. This is the key, that is the country name. Okay. Tokyo is there, Sri Lanka is there, Belgium is there, Canada is there, Australia is there, West Indies is there, Netherlands is there, right? So how do we then see the actual iterable, right? So we convert it into by doing take or collect. Basically what happens with take or collect is it brings you back into Pythonic form. Okay. So now this particular thing is actually a Python list of something, right? So within that list of tuple, first element of the tuple is the name of the country. Second element is a Pyspark iterable, right? So what we can do is we can use list comprehension. Hope you remember list comprehension from Python, right? So what we'll do, we'll have to put this in a proper structure. Now when I print this one, okay. So now you see that all the players with NG are visible. So first element is the key, right? So first thing, there's a list of tuple. Within that, the second element of a tuple is again a list of list. Each element within the list of list is all the rows having the same key, right? Which is NGA at this point, right? So I'll only show Indian players. Then I can do again. Now it is all Pythonic way, right? For item in list one or list equal to Okay. Is it India? Yeah. Okay. So from there, I can use Pythonic way of getting all the values. So from this point onwards, it's all Python, right? So if you see it, these are all something that we have already done in Python: list comprehension, and from there, now I have created another list, and on that list I'm printing it out. All these are Pythonic way of doing it, right? So directly there is no function from a grouped RDD where in which you can directly see the output, right? I mean, you can see the output, but it won't be in a proper structure, right? So collect, take, and everything will not give you the right structure in which you can see it, because the grouped data isn't iterable, right? So what happened here is I grouped all the
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.
group by. Okay. So what happened here is I grouped all the rows with the group by function. Grouped all the rows together as with similar keys together, right? So let's say key 1, and key 2, and so on and so forth are grouped together, right? So these group data are nothing but a Pyspark iterable, right? Because it can be iterated over. We can iterate over it and get the data out of it, right? So that is why they are Pyspark iterable. So, and directly they go into a grouped RDD as different rows, and you cannot see that because those iterable are the values of it, right? It comes in a key value pair where the value is an iterable, right? So this grouped RDD, you cannot see the value inside the, I mean, you cannot see the actual value in the sense that you can only see the key and the actual iterable address, right? So in order for you to get the data out of it, you need to again use list comprehension and bring the data out of the particular group Pyspark iterable. Okay. So don't again get confused. This particular group by function, whatever is the output acts as a key, right? And that key, based on that key, the group by function will group all the rows, right? So here the key already existed. We just took the 18th element of the row. In some cases, as you can see here, we ourselves generate the key, right? Using the function. We are saying that divide each row element by 2. Whatever is the reminder, you group it based on that reminder. So that reminder will act as a key, right? So 1 divided by 2, the reminder is 1. So the key becomes 1. Same here. 2 divided by 2, reminder is 0. 0 becomes the key. 3 divided by 2 is again 1. So these 3 rows will be grouped together, right? 5 divided by 2 again is 1. Reminder is 1. So all these 5, 3, 1, 1, they'll all will be grouped together. 8 again is 0. So the 2 and 8 will be grouped together, right? So in this case, there was no key available, right? So we had to use the lambda function to generate the key. Based on that key, the rows got grouped together. Okay. So next function is called as key by. So let's say I don't have a primary key in my data, right? I want to generate a new key in my RDD, right? So in that case, what I can do is I can use key by and create a key for each row. Okay. But only problem with this would be that it will, unlike map partition with index where it got added to the same row, right? Same list of rows, right? But here it will convert the row from a list to a tuple, where first element of the tuple would be the key, and second element would be the actual row value. That was the actual list, right? So our rows went from list to a tuple having the second element as the list. So earlier it was a list. After key by, it became a tuple where this list became an element of that tuple, right? So each row is a tuple if we use key by. Right? So that is a disadvantage you have to look into. Okay. But you can use map function on top of it and you can sort it out. So we will do that. Right. So my boss comes and says, okay, we need to put this in some Oracle database where the table is having a primary key, right? So we need to make sure that the key by function, whatever key it is generating, it should be part of the row, right? So first thing is take RDD top 10, and on that I will use key by. For each row, I will take some value. So row 0 has some ID. Okay. On that ID, I will multiply it with number of runs. What is number of runs? So I'll generate a surrogate key, right? 1, 0, 1, 2. I'll use matches. Okay. This should give me a new key. So now when you print dot collect, so take 10. Okay, so if you see here, this is my key, right? So it got converted into tuple. Forget these two. These are all group data. I'm not using them. Yeah. So if you see here, this was my actual row. It was a list, right? But after I used the key by function where I generated the key, that key became the first element of a tuple. So now each row is a tuple for me, right? Where in which the first element is the key and the second element is a list, right? So something similar, even in group by output, you saw the same thing, right? So the grouped key was together. I mean, a grouped key was the first element of the tuple, and all the rows that belong to that particular key were together, right? But that was group data set. But here, for each row, now the row itself has changed. Earlier, it was a list. Now each row is a tuple where the first element is the key generated by the key by function, right? Then for each row, what you can do is, yeah, so we already have some row number here, right? So we can just do max surrogate key plus row number. So that would ensure that whatever the existing key is there in the table, that will still follow on. I mean, these are all the newer keys. You get my point, correct? Yeah, I need a proper function. So let's convert to list takes RDD row, and first thing is list1 equal to list, and list1 dot append row, zeroth element, that is the key. Then what I'll do, list one dot extend, and I will take the RDD with 2, so 1, and return list. Now let me build correct structure. Build function method object is not subscribable. Built-in function or method object is not subscribable. Move to list. Gets RDD row. Did the naming create a problem? Let me data access. Okay, but for some reason this is not being subscriptable. How is it possible? Just give me a minute. I don't understand why. RDD row. Each row here is passed on to convert list. Hit that row. So RDD has a 0th element. It's showing correctly. Then one doesn't work. Yes. Ah, sorry, my bad. Had given the wrong braces. Yeah. Okay. So now I converted it back. where each row is a list. First element is the key that I've generated, right? For example, Rohit Sharma, right? And the second was the actual original ID column, right? And sixth one was the number of matches. So I just multiplied them and generated a new key, right? So as I said, there will be requirement as such, depends on the scenario, right? But that is how you can use key by and work with it. Okay. Okay, if there are no more questions, we'll go with the next transformation function, which is zip. Where's it with index codex? Okay. Sort by, we did it. Okay. Zip, what it does it do is it will zip two different RDDs together. Okay. So it will create a new RDD out of two different RDDs. And this is basically used to create a key value paired RDD from a single record value RDD, right? So I told you that we can have RDDs where there are only single records, right? Where each row is just one integer, right? Instead of having a list, each row is an integer. So in that case, the structure is not key value. If you have a list or tuple, the chances are that the structure is key valued, right? So for example, here we saw this is a single integer. Each row is one integer, right? Here also it's an integer, right? These are all single valued records, right? So what we can do is we want to create a key value pair records. That in that case, so we may come across a scenario where we have two different single valued records and I want to create a key value pair out of it. Right? Then what I can do is I can use the zip function. RDD4.zip 5. And now when I print RDD5. RDD5 is not different. Oh, sorry. RDD2 and 1. Okay, 5 doesn't exist. With same number of elements. Oh, okay. How many elements are there? It's same. Yeah. Okay, so if you see here, the last output, now I have a key value pair RDDs. Earlier it was all single valued records. Now each record is a key value paired RDDs, right? So that may be a requirement, but I'm not going to say that there may be a scenario. I don't actually know getting a real life example, but you may have different data sets. For example, you may have an RDD which has only number of all the runs scored by different players, right? And then you have player names as another RDDs. And you know that each of the player is related to the its own position in the particular first RDD, right? For example, Rohit Sharma may be here and he may have scored 100 runs. Virat Kohli may be here, 200 runs, something like that. So we know that there is some mapping between them, right? So then what we can do is we can use RDD2.zip function and zip them together. Okay. Unfortunately, real time, you will see there will, I'm not saying that there's no use case for zip. There'll definitely be, right? Yeah. Okay. Next is zip with index. Okay. So this is somewhat similar to key by, right? Like you can use the index number of each row, but here the index of each row can be used. Okay. And it works with any kind of, I believe so. Let me check. So now here instead of key by, Let us try to use zip with index. Okay. I'm just hoping that it would. RDD top 10. Index photo dot index. Yeah, if you see here, oh, okay, but it put it in a tuple. Yeah, it also put it in a tuple. So again, what I can do is convert to list. But here it is reverse. First element is the row, second element is the index number. So I need to reverse it. Then it has to work for both, right? So what I'll do is change the function itself. So that when you are actually doing some hands-on, you don't get confused. So in list one, I will extend this and append this. Okay. It got appended at the end. Okay. So these are the row numbers. Okay. So I zipped this RDD with its own index. Okay. So what happens is it will zip with the index number and create a tuple out of it. Right. So the row will be the first element and the index number, which is nothing but the row number, will be the second element of the particular row. Right. So it created a new row out of it. Right. So similar to key by, only difference is key by the keys first, right? So in key by, we saw the first element of the tuple was the key and second element was the actual row value. Here, first element of the tuple itself is the actual row value. And second element of the tuple is the actual key. I mean the row number or the index number, right? So this works when you don't have any surrogate key logic. We don't have any way to generate a key or anything. So we, instead of key by, we can use zip with index. Okay. So that's an actual use case. Next function, repartition. So we have seen that RDD gets partitioned, right? So this is my driver and this is my cluster manager, then slave machine. So this is my executor one. This is my executor two. And this is my original input RDD or input data set. Let's take it. Okay. So it got split into two. Partition 0 was in executor 1. Partition 1 was in executor 1. Sorry, executor. executor 0 will take. Okay. Partition 0, executor 0, partition 1 and executor 1, right? But over the period of time, there may come a chance where the data may grow, right? The next RDD, right? So this is RDD 1. So RDD 1 is your original input data set, right? And on top of that, you keep doing map, key by all these functions. The next RDDs, like, the zip with index or whatever it is, right? That's an input and that's an RDD only, right? The partition size of those RDDs may either grow or it may either shrink, right? So if it keeps growing, then your RAM, it may grow beyond the RAM size of that particular executor, right? If that happens, then you may get a memory out of executor memory out of memory error, right? So what you can do in that case is, let's say at this point, I created RDD2, right? RDD2 partition 0, okay? RDD2 partition 1, and on top of that I did some map function. So that map function resulted in a very big data set of RDD3, okay? RDD3 partition 0, RDD3 partition 1. So in that case, what happens is I may have to repartition this RDD3, right? So what I will do is, rather than sitting in two executors, now I will make sure that I get a new executor, and in that I will split this this RDD3 into 3 different partitions. Okay, so then I will make this smaller. This also becomes smaller, and the final partition. Now I have partition 3 for RDD3. So in between, then the executor got included and a new partition was created. And from here on, whatever manipulations I do on RDD3 will happen on all the 3 executors, right? So that I'm doing it, that's what that flexibility exists. So first thing is, till now I've been using only 2 executors, right? And suddenly within my code, I'm bringing in a 3rd executor and doing it, right? So that flexibility Spark allows you, right? And that function where all this calculation happen is done by repartition, okay? So you can also shrink it. So suppose you thought that, okay, RDD3 is very small, why have 2 partitions? I can put it in a single partition. Then it will go into one executor only. The entire RDD3 would go into one executor. And from there on, the next steps, whatever is there in my transformation, whatever is there in my code, right, it will happen on that particular single executor itself, right? So that is again a performance improvement perspective also. Coalesce can repartition play a very important role, right? But most importantly, right, when we most important use case is when you want to have a single file. So what happens is, you have 2 partitions for your RDD. Let's say this is executor 1 and executor 2. So this is part 0 of your final RDD, right? Part 0 and final RDD part 1. Right? So when you use some action operation like writing a file, collect is a sending it back to the driver and displaying it, right? Collect, take, and everything. But there's a function called a save as text file. So save as text file will write the file to the storage layer. But how will it write? Each partition will write it separately as a part file. Okay. So there'll be part 1, part 0 file, there'll be part 1 file, right? So 2 different files would be there. Let me show you that. Let's say I do it with this, right? Structure dot save as text file. I give the location as content. and your folder output 1. Now if you see output 1, okay, so now if you see, there are two part files, right? So by looking at the output of the file output folder itself, one can guess how many executors were involved, right? So there were definitely two partitions for the RDD. That means most likely two executors were involved, right? So I don't want this. My client says, no, yeah, I cannot go to two different files and read it, right? So in that case, what we can do is I can call the transformation operation repartition. I can repartition it to 1. Oh, I get an error, sorry. Now when I do output 1, I'll see only, right? The reason is there are two partitions to this particular RDD. They got clubbed and put into a single partition using repartition, and that repartition then got written out using the save as text file action operation, right? So only one file exists now. Yeah. So we have two functions with the same functionality. One is coalesce, other is repartition. Only difference between, I mean, there are a couple of difference, however. Coalesce cannot increase the number of, so if there are two partitions, I cannot increase it to 3. Okay, I'll get an error saying that. Whatever it is. Oh, one thing. So a couple of differences are there. One is how coalesce can repartition work. Coalesce will use the existing partition to minimize the amount of data shuffling, right? Whereas repartition will create a new partition itself and does a full shuffle. So what does that mean is, if I'm using coalesce, let's say this is my driver. This is my cluster manager. This is my worker node 1, within which we have executor 1, and then we have worker node 2 with executor 2, right? So now this particular RDD has two partitions, partition 0 and partition 1. Let's go with that. Okay. So when I do repartition, it will create a new executor itself. Within that executor, let's say I did repartition 1, right? So it will merge these two RDD partition into a single partition, right? If same thing was to be done using coalesce, what it does is it won't create this new executor and a new partition. It will make use the existing partition. It will pick one of the existing partition, either this or this, and it will do a data shuffle. That means it will move the data from here to here, or if this is the one it picks, then it will move from here to here, right? So whatever it is, so what it is doing is it is using the existing partitions. Okay. However, repartition will create a new partition in itself, right, and do a complete full reshuffle, right? All the data will go right from here and here. So that is one of the biggest difference with repartition. So if the data is too huge and your existing cluster, whatever existing executors are not able to manage, so in that case, repartition is a much better option than coalesce, because it will pick a new executor where it is capable of holding the data, right? However, coalesce is faster because the data shuffle is minimum. Only this RDD data and this RDD partition data has to move to here, right? However, with repartition, I'm moving two RDD partitions to a new location. Here only one RDD partition is being moved to a new location. So it is half times faster than repartition. Right? But again, if this particular executor had only 16 GB, right? And by adding the new the other partition 0 of RDD1, I'm adding it to partition 1 here. It may grow beyond 16 GB and I may get a memory error. Right? But if I've done repartition, cluster manager will make sure that it picks a slave node where at least the combination, maybe 32 GB RAM is free, right? So that is another advantage with repartition. So that's how you need to think. If merging the data, merging both the partitions or three partitions, how many number of partition into a single partition is going to be memory wise expensive, then go with repartition. But if you see that the data is not going to grow beyond the RAM size, then you can go with coalesce because it is faster. The data shuffle will be less, so the process overhead is reduced. So hope you got the difference. So first action operation is reduce function. So reduce function is some kind of aggregation that you want to perform on. It's a final result oriented operation, right? All these action operation do, it does some final result oriented operations. Take, it gives you the first n row values, right? It will display those n rows. Count will give you the total row count, right? Collect displays all the rows within an RD, right? Save as text file is writing it into a file in the storage layer, right? So these are all final result oriented operations. So I'm not trying to create a new RDD out of it. Okay. So those operations are called as action operations, right? So first one is reduce function. So reduce function does what? It is actually an aggregation function. It will take all the values of the RDD and perform some sort of an aggregation. Okay. So in this case, if you see here, it created an RDD with 5 rows, right? On that, it is using the reduce operation where it will traverse each row, and to that each row, it will perform some final result oriented aggregation. Here it is just adding each of the row values. So finally, whatever the output will be 1 plus 2 plus 3 plus 4 plus 5, right? So which is nothing but 10, 15, right? Similarly, we will do it in our case. This is a very simple example of adding the row values. What we will do in our case is, let me think of a genuine scenario. I think, let me see what I've done earlier. Don't see reduce. Connect is there. Okay. Partitions. What I'll say, okay, fine. If my boss comes and says, okay, do one thing, we have Indian player list. We saw that we were able to get Indian player list. Where was that? Here, right? Let me open this up. Yeah, so we group the data and we group by the country, right? So now we have group by country list. So my boss comes and says, we have to show the dashboard where we are going to display total number of runs scored by all Indian players, right? So in that case, we have already grouped the data. So first thing is we group the data, and from the group data, I took out all the Indian players into a separate list, right? Before doing that, let me, so I already have the group data, right? On the group data set, I took it into an Indian player list. Let me add this player list back into a new RDD called as Indian players. And on this Indian player, rather than doing all this, okay, fine. There's a very big method. Why do all this? I'll use filter function. Okay, that's the best way. With the existing zip data. Okay, so we'll use the zip with index. Yeah, okay. So with zip with index, there's another print. Yeah. So we have done till group zip with index, right? So we have a data set where the last last number is the actual row number, right? Okay, all that is done, right? Now my boss comes and says, no, yeah, I want to find out all the total number of runs scored by Indians, right? So that is each player 0, 1, 2, 3, 4, 5, 6. Sixth element of each row shows the player's individual runs. But now to get the total runs, first I will do is RDD India, and then I will do correct structure, filter. What is the column? Column value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 index. So that's index number 17. Lambda row 17 equal to India. So equal to India. Okay. So this will make sure that only Indian players from correct structure goes to RDD India, right? So now I have all the Indian player records. Now all I need to do is I need to perform some aggregation. RDD India dot reduce, and what will reduce do? Take each record and pass it to the function here. So I'll show a different way. I can do this as well. Okay, import mathematical function from import and gets imported. And it's not a math function operator. So I put it in a single row, my bad. So after this, what I will do is RDD India score, RDD India map number row where total number of runs 0, 6, right? Element number 6 of each row is this run scored by players, right? So all the now what I did is from the Indian records, right? So I got at this point I got all the Indian players records. So each row in RDD indicator, RDD India is having information about Indian players only. So on that I use the map function, and I'm only returning the 7th element of each row, which is nothing but runs, right? So if you see RDD in score, now it's a single valued RDD where each RDD is a integer and it is nothing but the players runs, right? Collect. Yeah. So if you see here, the score of each player, total number of runs scored by each player, each Indian player, I put it in a new RDD, right? So on that RDD, I'll do reduce, and I will get the total number of runs, okay, scored by India. So if you see here, I use the Python operator add, but rather than that, I can also use lambda function. I'll show you how. Lambda current value plus previous value, current value plus value. Okay, you don't need operator as well. So what is happening here, right? So what is CV and PV? Basically, these are all not reserved keywords. I've given it myself. I will change it so that it gives a much better understanding. Current value and previous value. Okay. So what happens with reduce function is when you're using reduce function, it takes in a particular shared storage space. Okay. So there may be a shared storage place where the previously calculated output is stored. Okay. Initially that output is 0. Okay. So when I did current value plus previous value, the current value would be the, for example, first time it will be the first row, right? So 2633, right? And previous value is 0, right? So I'm doing current value plus previous value, 2633 plus 0. So it goes and stores 2633. And now the previous value will hold the 2633, right? Next time current value is again 2633, right? And previous value is also 2633. Current value plus previous value will be around 4633, and that will again overwritten in previous value. Okay. Now previous value's new value is 4633. So now 1617 is the current value. Previous value is 4633. So current value plus previous value 4633 plus 1617 would be around 370 270 6770. Okay, so the previous value now will be 6770. Okay. Now current value will be 1605. Previous value will be 6770. Again, I'll do that. So like that, it keeps adding. Finally, whatever is there in the previous value will be the result. Okay. So this again, I'm telling you, these are all not reserved keywords. You can give whatever you want to, but the second argument of the lambda function will always be a shared variable. Okay. And the shared variable is what will keep getting updated at the end of the reduce function. Okay. Is that clear? Okay. So either you can use the add operator or you can do something like this. Okay. You can also do anything. It doesn't always have to be plus. You can do any kind of aggregation, multiplication, division, whatever you want, module operator, anything. Okay. But since, as I said, previous value will always be 0, right? Initially previous value will be 0, right? So 0 into 2633 is 0, and 0 again the previous value will be 0. So when the next current value, which is 2633 into 0, again 0, 1617 into 0, again 0. So that 0 will again be stored in previous value. So like that, 0 will never keep going. So that's why you see the final output being 0, right? So that's what I said. Previous value initially will be 0. Okay. It will be a shared variable having the value 0. So you can take the current value, and on top of that, you can do anything you want.
Let's have a quick quiz question, guys, and the question is, which of the following are the features of Pyspark? And your options are lazy evaluation, fault tolerant, persistence, or all of the above. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.
Next is take ordered. Okay. So till now we have seen take, right? So we did take 5, it will give me the first 5 rows, right? So first 5 rows in the order in which it was inserted, right? So these are my first 5 rows. It'd be 1, 5, 3, 9, 4, because they were inserted in that manner. But take ordered will sort the entire rows, right? If this is how it was inserted, it will sort it in some manner. Okay, we cannot basically it sorts it in ascending order. But again, if it is not an integer, it can be a string or anything, it will define its own way to sort it, right? So it will sort it, and then once the data is sorted, once all the rows are sorted, from there it will take the first n rows mentioned here. Okay, so that is the difference. Take will not change the order, it will keep the original order as is, whereas take ordered will order it and show it to you. Okay, so if I do okay, so it ordered in ascending, it sorted out all the scores in ascending order. From there, it showed me the first 10 rows. However, take 10 gave me as is without changing the order. So this was originally the first row, this was originally the second row, but here I cannot tell you what was the actual original row number for these, right? So that is the difference between take ordered and take. Okay. So the next is count. It will give you the total number of rows. It will give me the total number of rows. Okay. Collect, again, I told you, first of all this action operations, collect, take ordered. What happens is, I'm a driver here. Okay, dot map function within map lambda row length of row. Okay. So basically this will give me the total elements within a list. If you know, we have seen in Python, right? Length will do what? Whatever is data type is given, it will give you the total length. So if it's a list, it will give you the total elements of a list. Right? So now when I do column count to will give me the total column size. But as such, there is no function for it because the column concept doesn't exist in RDDs, right? We have rows in an RDDs, but rows can be anything. It can be a list, it can be a tuple, or it can be an integer, it can be a string, right? So in that case, where is the concept of columns there, right? So that is why we don't have it, but we can use map function and define our own logic, right? Okay, so I have a driver, right? And I have executors. So when you call action operations like collect, take, and everything, right? So the data then, when you use such action operations, the data then moves from each of the executors to the driver's RAM, and from that RAM, it is displaying it to the user, right? Whoever is calling the action operation, right? So whenever I'm doing this collect operation, whenever I'm doing count, collect, first, take order, all this data, what is happening is however number of partitions were there zipped for this particular RDD, right? Zip WI. Let's say zip WI had two RDD partitions, right? So both the partitions would be combined, and then all the data would be sent to the driver's RAM, right? So if the data zip VI, let's say it was 16 GB, and my driver's RAM is only 2 GB, right? Then it will fail, saying out of memory error, driver is out of memory error, right? So that is why these operations are very costly. You have to be very careful how you are using this, right? However, I told you one action operation where that doesn't happen, right? So reduce sends the data to driver, first sends the data to driver, take order does it, take does it, count does it, collect as map does it, save as text file, however, doesn't send the data to RDD. Each partition will write the data separately to the storage itself. Here there is no place where driver is involved. Okay. However, max, min, sum, mean, variance, they are also sending data back to the driver, right? But all of them, most of them won't cause. If you see reduce, basically it gives you one single output, right? First will also give you one output. Take ordered and take, you can take, generally first 10 rows, 20 rows, 30 rows. It may not cause a problem. Count also will only, give you the final result, right? So all these may not cause a problem. However, collect, take, and take ordered may create. Collect will display all the data, right? So if the RDD had 1 million records, it was split into 500,000, 500,000, two different partitions. When you do collect, both those 500,000, 500,000 will be combined, and 1 million records will be pushed to the driver, right? So the driver may not be able to hold it, right? Same thing in take. You may, if you do take 10, 20 records, it is fine. But if you're done, take first 1 million rows, right? So all those first 1 million rows will move to the driver. Okay. So driver may not be able to handle it, right? So that is a very costly operation. We have to be very careful with it. Okay. Yeah. So collect, we have seen, it just takes whatever data is there in the RDD and displays it, right? So basically it is traveling back to the driver program. Okay. Should be used wisely, as all worker nodes return the data to the driver node. So that is why it is very important that we are careful with it, right? Save as text file, again, I've already shown you. Each partition of the RDD will write it as a separate part file to the storage layer, right? One thing here is, every time you are writing it, you have to change the folder name. Okay. First of all, we cannot give any customized username, because as I said, each part has to write it separately, right? So I cannot have a custom file name, right? So that is not possible. So all your Spark output files will start with part. Okay. You can, on top of that, you can use Python and change it. Okay. But there's no way using Spark you can write it to using a customized file name. That is not possible, right? Second thing, every time I write it using save as text file, I need to keep changing the file, right? Or else it will give me an error. So now I've already written it to the folder 12. If I do run it again, I'll get the error, file already exists. Okay. output directory file already exists. Okay, so it doesn't have the ability to overwrite this content. Okay, so that is another disadvantage. However, as I said, core is not being used much. So in today's time, that is not a problem. People are generally using data frames, not RDDs. Right? So in data frames, we have all that option. So data frame is a much better data set than an RDD. As I said, first thing is it is a structured data set. Right? We have rows and columns in data frame, but in RDD we don't have that. Right? Second is we have some extra functionalities like we can override existing folder. We can append it to the existing folder. All those modes are available. Okay, so that is your save as text file. Next action operation is for each. We'll come back to for each and for each partition. Fine, we'll do max, min, sum, variance. Right? So these are all mathematical formulas. Right? We can max, median, standard variation, deviation. Okay. And max, std variance and sum. So okay, so basically this is the minimum. No, this is minimum. 0 is the minimum rounds. Maximum is 2633. I think then the third one is what, mean. Yeah, mean is basically your average, right? Basically all your mathematical statistical formula, right? Mean is your average, standard variation is standard variance, sorry, standard deviation, then we have variance, and then finally the sum is the total sum. So let's say my boss comes and says that we group players by the country and we display that in the dashboard. Right? So how do I do that? I use the group by function, correct? And if when I do this, I told you that it will show the second element as iterable. First element will be the key generated by the function, group by function. Second element will be a iterable, which will have all the rows that are having the same key, right? So in that case, I cannot print it as is. It doesn't look good. I mean, you cannot read it. So in order to make it readable, I will have to convert it back into Python. Right? So that's why I need to use this collect function. So when I use this collect function, the data gets converted into a Python list of tuples, right? In this case, it is Python list of tuples. Otherwise, it will be whatever Python list of something, right? In this case, it is Python list of tuples. And from there, I am doing list comprehension and converting the second element, that is iterable, Pyspark iterable, into a Python list, right? So this is a genuine use case where you would require collect, right? So this is the only way I can display the correct format in which you can see the first element as the country name, second element as all the players who have played for that particular country, right?
Okay, sure.
But others, as I said, troubleshooting, majorly collect, take, and all, they're used for troubleshooting so that you get an idea at which point what my data set had, right? Okay, if that is clear, then we'll go back to for each and for each partition. Okay, so we have seen map and map with partitions. That is the transformation function. Okay, for each and for each partition also works similarly, but their action operation, meaning they're not going to create a new RDD. They're going to do some final result oriented operation. For example, we saw that there is a limitation with save as text file. right? One is you cannot create a custom username, right? So we cannot give custom file name, sorry, right? However, I want to give a custom file name. Then what do I do, right? And I want to write it in a single file without having to change, without having to use repartition or coalesce, right? So what I can do is I can use for each. So what for each does is it will traverse each row in the RDD and pass it on to the function that is defined inside the for each. And whatever is defined inside this function would be a final result oriented operation. For example, we will now take this data. Okay, so I want to create, my boss comes and says single CSV file. You create a single CSV file, and first thing is save as text file. We only save it as a text file. Okay, and we do not have any other function where we can write it as a CSV file or something. Right? So what we can do is we can take the RDD and do for each, and I'll say save as, I will create a function called as save as CSV. Okay, and then I will define save as CSV where RDD row is passed, and I will bring in Python with open. So I think I've shown you how to write it in write to a file using Python. File name is content. I would say final output.csv plus mode f dot write lines. So now when I do this, what's the error? Right, argument must be a string, not integer. Correct structure, what is correct structure? Right, argument must be string, not integer. But here it's not an integer, it's a list for each. Wait, let me change this a bit. Open CSV in append mode. Still the same. Must be a string. I'm not using right. can't even see line numbers. Okay, what if I do this and still the same? Item 0 expected string instance and from okay. From now, I will do one thing. RDD, I get the first element. Let's see what happens. For some reason, okay, I could only write the, so there's some problem with the write lines function. I don't know why we never passed on integer, but it was still saying expecting string. Okay. I don't know why, maybe some issue, but whatever it is. So here, if you say if you see in this case, I'm able to write everything in a single file, right? And I'm giving a custom file name. So this can be done using for each, and within for each, I'm doing some final result oriented operation, right? So what it did is it traversed each row within the calling RDD, passed it on to the function. On that function, in that function, I'm doing some final result oriented operation on the given row, right? So what I'm doing is each row that is being passed, that row I'm directly writing it into the final output file, final output.csv file in append mode, right? So same thing we can do in for each partition. Only thing is, instead of row, it will be an iterable, and we are doing it in less number of function calls, right? So here, RDD partition, RDD partition, open the file, item, start this. For each partition, save as CSV1. Sorry, save as CSV partition and final output. Okay, so same thing I'm doing in for each, what we did in for each. Only thing is, in for each, it is traversing each row. In for each partition, it is traversing each partition. So if RDD was partitioned 2 times, it will push that both those partition into this particular save as partition function one at a time, one by one, right? And I'll take that RDD partition, and on that I will traverse each row, and then I'll write each row to the final output. So this is the similar thing what we saw in map and map with partitions, right? So the output will be the same. What is it? RDD partition is not defined. It's defined here. Oh, sorry, spelling mistake. Okay, so now if I see output 1 also, there's no difference between how it worked. The output is the same, right? Both the outputs were same. Only thing is how many times the function was called, right? Save as CSV was called as many times the number of rows existed. If there were 64 rows here, this particular function was called 64 times, right? Whereas this function, since correct structure had only 2 partitions, so this function was only called 2 times, right? So it is much better in terms of better than for each. Okay. So what happens? Suppose I am an Infosys employee or Cognizant employee or TCS, whoever, whatever it is. I go on site on some visa and I have opted for insurance. My company gives me insurance, right? And that comes from HCSC, right? So every time I purchase a medicine, I fill out a form and claims form, right? And I send it to HCSC, right? Sorry, send it to Infosys first, right? Infosys then will collate it and then will send it to HCSC, right? So that is how it works there. So when I send it to Infosys, Infosys will wait for other claims to come in, and then they will create their some Excel sheet or some sequence file or something, right? In that they'll have all internal information also, like Infosys employee number, managers employee ID, and all those stuff. Something that is not required for HCSC, right? But either ways, they'll send the same data to HCSC, right? So likewise, Cognizant will also do, okay? They may send some other extra information, something and all. But HCSC requires only certain stuff. What is the subscriber ID, right? What is the claim ID? And what is the drug name? What is the drug version? And all those quantity, how much was bought? What is the uh, amount that was bought, right? So these are the important information for HCSC. They don't care if Infosys sending the Infosys employee number and all those stuff. For them, that is of no use, right? And the bigger problem is Infosys sending like this, Cognizant is sending some other format, right? They may be sending uh, employee ID, sorry, subscriber ID in the beginning, whereas Infosys is sending subscriber ID at the end, right? So format, structure, everything is different, right? So what they do is they'll dump all this in the raw layer, okay? So they will dump all these files in the raw layer, and our job and they'll always fix this. That is the only thing that HCSC is strict about. I don't care what kind of data you send, but whatever you send, it has to be in fixed with, and it has to come with some mapping file. Okay, mapping file, their own HCSC BA will sit with Infosys and map it out. Like, okay, if my fixed width file is like this, okay, so this much from 0 to 30 positions, you'll get the subscriber ID. From 31 to 64, you will get employee ID or claim ID, right? From 65 to 90, you will get drug version. From 90 to 120, you will get subscriber name, and so on and so forth, right? Such kind of mapping should also be available. So either they give it on their own, or HCSC BA sits with them and gets the mapping file. Okay, so that is also dumped in the raw layer. Okay, so we take these two information and we have created a generic code, right? So all that generic code requires is the source file and the mapping file. Once you pass these two, it will convert the existing client files and put it in a common structure. That means Infosys file, a Cognizant file, TCS file, they're all different structure, different format. It will convert it into common claims format, CCF, okay? And it would be a JSON file. So it will create a common claims format and store it in HDFS. Okay. So here, first of all, basically they're doing ETL, right? You're extracting, then transforming, and then storing it. Right? First question is, the data is not that big, right? Not every day, if Infosys has a million employees, hardly 1,000 people or 2,000 people would be going to pharmacy to buy something, right? So you would have 2000 claims per day from one client, right? So for that, you're running one job in big data, it doesn't make sense, right? But as I said, they're expecting things to go big, and it is not just the client files. They're giving lesser information than what HCSC wanted, right? So it's not just drug name and everything. Tomorrow they want to add demographic information, which store they brought, what is their ethnicity, what kind of area they're living in, all those kind of information they're not yet started taking, right? So the reason behind going with big data, even though the data is small, is they're expecting the data to grow big sometime in the future, right? Okay, so this is what we do. We take the raw layer client files and mapping file and push it to our Spark code, and that Spark will convert that input file into a common claims format so that all the files have the same structure. It can be Infosys file, TCS file, it can be Cognizant file, but all the formats will be same at the end of the day in the gold layer. From there, they have another layer where they do some reporting, right? So they have a reporting layer. They use the CCF and build dashboards. Maybe like per client, they made, okay, how many clients, how many claims we have got from Infosys per day, per month, per year wise. They also do some analysis on drugs, like, okay, this drug, how many people are buying in US or in a particular area or by particular client, right? So different levels of dashboards, right? So that is, I think, I haven't seen this part, what actually they do on top of CCF, but this was our job. CCF creation of the common claims format was okay. So my code has 3 modules. Okay, one is the model.py. This is where all the main logic should go. Right? Generally, I mean, it is not a standard per se, but when you talk about model, people expect that, yeah, this is where the business logic is written, right? And environment.py is where I'm setting the environment. Okay, so first we'll start with environment class, right? Environment module. Okay, so environment module has a class called as environment. Okay, and within that, the constructor, if you see, we have seen how to do all the constructor and stuff in Python, right? So in constructor, I'm setting both the class variables, that is Spark and config, right? And Spark session object is created. Okay, so this is the newer way of doing it. I told you that there are a couple of ways. The older one was to create a Spark context object, and from that Spark context object, you have to create a Spark SQL context object and use that SQL context object, right? And use that Spark context object and the SQL context object. But here it is not required because Spark session is, this particular class is like a child class of both the Spark context and Spark SQL context. Okay, so this is something that people have started using in the newer versions of Spark. So Spark session object is what being used here, and this is the new way of creating the Spark. Starting your Spark code, right? So next comes the config object. Config variable, right? And what we are doing is we are calling a parse JSON function, right? And which is taking some config file and returning as a dictionary. Okay. So returning as a value of a dictionary, but ultimately it is returning another dictionary itself, because if you see config JSON, it's the dictionary of dictionary, right? So this is the main dictionary, and these are the keys: local dev, SIT, and prod. So what we are doing here is we are having a common config file for all the environments. Right? So there's a chance that this code may have a different input path in dev, different input path in SIT, different input path in prod, right? Or the output path may be different or something like that, right? So we cannot every time, for each environment, go and change it and then run it, right? It is not feasible because it is all working in CI/CD process, right? So once it is deployed to dev, the same thing goes to all the environments, right? So that is the reason why we need to maintain a common config file. But then for across environments, how do you maintain a common config file, right? So that is where this pass JSON function comes into picture. So it takes this particular common config file, and from there, first thing is it checks if each of the, if there is a, in the cluster, right, in your cluster machine, if there is an environment variable called as HAC environment, right? So this is something that the Hadoop admin would have already set it, right? So you would have taken the, you would have asked the admin, please, boss, you create a environment variable called as HAC environment. And accordingly, if it's a dev cluster, you put the value as dev. It is prod, you put it as prod. If it is SIT, you put it as SIT, right? So let me give an example of that happens. Let's see. Okay. Just running. So root exit. So, and root. Root. Okay, so now let me go to putty 192.168.0.1. Yes, change 20. Okay, apply. CTL start. Stop IP table 68. Yeah. What did I do? 192.168.0.115. System CTL start IP tables. Stop tables. Stop one. Okay, so how would I have set the environment variables? So in each machine within the cluster, let's say it's a production cluster, right? So they would do export, let's see, $, let's see environment, CSC environment equal to SIT. Okay, let's say that. no dollars. Okay, so now when I do echo dollar XCSC, okay, I get the value SIT, right? And in Python, if I want to access this variable, let me open the shell. So I just need to, okay, there's 2.0, Python 3, right? So I told you there is a library OS, right? And within that, we have a dictionary called as environ, right? So os.environ, and the key would be HCSC environment. Okay, so if I print this out, you'll see that it is giving me the value SIT, right? So that is exactly what I'm doing here. So I check if there is a key within the environment, if the admin team has defined it or not, right? Because there's a chance they would have forgotten, or they would have said, okay, for dev and all, we are not going to do. For other environments, we will do it, right? So if they have defined it, then in the environment variable, env variable, I will get the value of the particular environment, HCSC environment, right? If they have not defined, by default, I will consider it as dev. So that's what I said. They may say that, okay, in dev and all, why we should do it? It's a waste of time. I cannot log into every machine in the dev cluster and do it. It's a time waste for me. I will do it in SIT and prod. So they may say, or they may have forgotten, whatever it is, right? So we do that. Okay. Then we open the config file that we have passed in, right? So it has gone into config file, right? We open that particular config file, read the entire config file and convert it into a dictionary. So if you see here, if you see the config file, it is a dictionary of dictionary, right? So this entire thing is read, right? And is put into the variable config dictionary, right? But within that dictionary, we only need to pick those values that are applicable for that particular environment. So if it is SIT, HCSC environment variable is SIT, then I need to pick only this, right? So how do I do that? It's a simple thing. We know that this is all the key, all the environments are key, right? And these keys are actually the value of the HCSC environment variable, correct? We saw that it is SIT, right? So now we saw SIT. If I had a dictionary, for example, let's say dictionary 1 equal to SIT, and the value is the okay. So now I can use first thing is I will set env equal to os.environ print env. Now print dictionary 1 and env. So what is it going to print? It's going to print this, right? I mean, it's going to print this value. This is SIT because I'm giving the key as SIT here. env has SIT, so I'm going to get the value for that particular key, right? So now if you see, it's saying this is SIT config. Only difference between this and the configuration file that I showed you is that the value itself is another dictionary, right? So when I am returning the config dictionary, but only the values for that particular environment, that means if it is SIT, it will only return this much, okay? If it is dev, it will only return this much, right? If it is prod, it will only return this much. So this is what will be returned by this pass JSON file and will go and sit in the config variable. So now at this point, my config variable is pointing to, config variable has this, okay? So it's a dictionary having 3 keys: in path, out path, and map file, right? So was this clear how environment specific we are able to now put it in the config file? Okay, sorry. If you are able, how we are able to pick environment specific configs from a common config file, right? So this is a very standard approach to how we deal with config files and how we design config files in Python, right? Okay, so then we have two getter functions. That means basically this comes from Java concept, right? What is getters and setters? So basically it is getting you some class variable or something, right? So in this case, getSpark is returning the Spark object, Spark session object. Config is a dictionary, right? That is environment specific dictionary. So get config will give you that, right? So now let's go to model.py. Any questions on environment.py? Okay. So if this is clear, then we'll go to the next module, model.py. Right. So in model.py, I'll just give a brief and I'll go back to the main one so that when we'll come back to this later. Right. So we have a class called as model within model.py, and within that we have a function called as split data and get column info. Okay. So these are the two important functions. We'll see what each of them do later. Okay. We'll go to run.py. So run.py is my main function. Okay. For some reason, it's not taking it. Yeah, okay, fine. Yeah, so first thing is in my main run.py, which is my main script, I create a main function. As I said, in Java, that may be a requirement, but in Python, it is not. So I can name it anything I want. I've just call it main so that it may, kind of easy to understand to programmers, right? Because they're used to seeing main function, right? So that they know that this is where the actual execution starts, right? Okay. So we have created a main function, right? So first thing we did is we created the object of environment class and model class, right? And we have imported the modules here, right? And then I've created a Spark session variable by Spark session object here by calling the getSpark function. So I use the environment object to call the getSpark function. And I told you getSpark function does nothing but return the Spark session object. So when I created the environment object, the constructor got executed, right? So Spark session object and config dictionary got already set at this point itself. At this point itself, it was already set, right? So all I need to do is call the getter function, right? So getSpark will give me the Spark session object. Get config will give me the environment specific configuration dictionary, right? So from that config dictionary, I'm taking the in path. So if I told you it has 3 variables: in path, out path, and map file, right? So I'm taking the in path and assigning it to the variable in file, right? And then I'm generating an epoch time, right? So epoch time is nothing but Unix specific time. That is nothing but the number of seconds that have passed since January 1st, 1951, right? I need that because as I said, I think in last session, right, when we are writing a file to a particular folder, right, in Spark RDD, we do not have the option to override it, right? So if I'm saying that output path is this, every time it will try to write it, it will give me an error that folder already exists, right? So the first thing is the folder shouldn't exist, right? And even if it exists, it shouldn't have anything in it. It won't be able to overwrite it, right? So what we do is basically every day when we write the file, we change the name of the output. So this would be my final output path, right? Epoch seconds. So if I run it today, it will be output underscore whatever the number of epoch seconds is. Tomorrow it will be something else. Tomorrow, day after tomorrow, something else, right? So that is why we are calculating the epoch time here. Okay. Next, mapping file variable will have the path where mapping file is configured, mapping file exists, right? From the config file, right? Then finally, out file variable will have the output path, right? This path, as I said, and I'm concatenating with another string underscore and then the runtime, right? So this is what the folder would look like. Okay, this is what the folder would look like. Okay, then I'm creating an RDD base file called as base file. It is taking the Spark session object. Within that, we have Spark context. I think I showed you last time, right? If you're not using Spark context, if you are using a Spark session object, within that Spark context is available, right? You can call that and text file. You have seen this transformation. What does text file do? It will read all the lines of the file and it will create each line as one big string, right? So this is one big string. So my base file RDD has each row has one big string, right? So first thing what we need to do is we need to take this each row as a string and need to break it as each row as a list, right? So how do we do that? For that, I need to know that within this particular big string, from this position to this position, it is the subscriber ID. From this position to this position, it is claim ID. From here till here, it is drug ID, and so on and so forth, right? I need to understand that. So how do I do that? I read the mapping data. Okay. So if you see here, I read the mapping file, right? Again, mapping file also will go as a one big string. Each row in this particular RDD at this point will be one big string, right? So on that, I'm calling the map function, right? Oh, I forgot to show you the map. Yeah, so this is my mapping file, okay? The mapping file will have 3 columns. Actually, it has n number of columns, okay? It has another column where actual business logic, if there is no function, if there's a new function that needs to be executed and all the stuff. So client would give that as a entry to the, they would do it in the mapping file itself. Okay, just give me 1 minute. Yeah, but for our now this is just a sample of the actual code, right? I have not written the entire code, right? So here I'm only taking 3 columns, right? One will be the column name, the second is the starting position and the ending position. So if I look at the mapping sheet, I should be able to tell that, okay, from the input file, the position 1 to 32 is the, what is it? It is subscriber ID, okay. Patient ID is from 33 to 64. Okay, so this much is patient ID, right? First name is from 106 to 140. Last name is 141 to 174. Drug version is this. Name is this. So on and so forth, right? So all this information is required. Otherwise, you cannot break the fixed width file into a list, right? So I need this information. This is what is there in the mapping file. And at this point, this entire line goes as one big string, and that is each row in the RDD here at this point, right? So then I call the map function on top of it, where I'm traversing the row and I'm converting the string row into a list row, right? Yeah. So what it does, we have seen this in Spark core example as well. It will take each row, which is now a big string, and on that I'm using the Python string split based on the comma, right? So based on the comma, it gets splits into a list, right? So now each row is a list having 3 elements. Okay, that would be at this point, right? So at this point, first at this point, my RDD is each row is a string, but after that, after this map function, my RDD is each row is a list, right? And on that, finally, I'm applying the filter function where I'm saying that the first element of the row should not have column name as its string, right? So that would mean that I am removing this particular row and all the other rows will get inserted into the RDD mapping data. Okay. So we have done this in multiple steps, right? Here I've used a single step to do it because Python allows it. It's called as monads. Okay, so instead of these 3 steps, I put it in a single step. Okay, so I created mapping data RDD, where in which at this point each row is a string. Used map function on it, and each string row got converted into row of list, right? So on that row of list, I'm using the filter function, and I'm saying that filter all the rows where column name is not part of the first element of the row, right? So it will check each row's first element, and if it will see that, okay, if column name is not there, then it will add it back to mapping data RDD, right? So my mapping data RDD now has each row where each row is a list, right? And that particular RDD, I'm passing it to a function within my model class called as get column info. Right now, we'll see what get column info does. So get column info takes the RDD mapping data, right? And on top of that, it calls the map function. Okay, and in that map function, it is converting the list, each row as a list, to a dictionary where the first element of the row will be mapped to a key called as column name, and second and third element of the row will be the value for the key position, right? So let me give you a sample in Pyspark, right? First, let me start. Okay, let me go to slave 1. Safe mode, okay. Do DFS admin, safe mode, leave. Safe mode is off. First thing is for the project, we need to create this location in HDFS. Okay. This. .0.36. Yes, sir. Here it is. Yeah, so this is my config file. So I need to create this location, right? Slash pvm 3700. Within that input. Okay, and there I need to put this. Okay, so yeah, so this is the correct file. Okay, and first thing is let me go back. Let me just print. So $4 CSC. I need to remove this.
Let's have a quick quiz question, guys, and the question is, in memory processing of large data makes Pyspark ideal for dashed computation, and your options are virtual, real-time, dynamic, and static. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.
Need to set SSC and right. Now let me go back to slave one and okay. So now let me start Spark. Before that, I need to create Hadoop DFS mkdir slash pvm minus p slash pvm 3700 slash mapping. It's not correct. So this will create the folder in one shot. It will create this folder and this folder in one shot minus p. If I done mkdir, I have to first create this and then I have to create this. So rather than that, I'm just doing it in one shot. And then mapping input and output. Okay. Input, output, and mapping. So let me see, same thing is available. Premium 300. Okay, fine. Now move as Hadoop, DFS, put suit slash PVM 1700. Within that, I have Pyspark RDD as an example of PVM 3700 text. Text PVM 700 inside input. So next is mapper.csv, and that will go inside PVM 3700 mapping. Yeah, so all this has been set, just confirming. Okay, mapping file has it, input file has there. Okay, fine. So first, I mean, before we go further into the code, right, I'll tell you what this particular thing is doing, right? So first thing is we will start by Spark shell. Okay, I'll show it in shell. Okay, so now let me first read it. Mapping data equal to, so here I'll use Spark. So I'll use SC only, right? So first step is we'll go what we did in here, right? So I'll read the text. I'll use the text file and read it. PVM 3700 slash mapping slash mapper.csv. If you see mapping data dot collect, you see that each row is a string. So if you see, this is first row, this is second row, this is third row, this fourth row, and so on and so forth, right? So I don't need in a string format, I need it in RDD format. So what I do, mapping data equal to mapping data dot map lambda row dot split and now when I do collect, you see that each row is now a list, right? So this is first row, this is second row, this is third row, this is fourth row, and sorry, yeah, this is fifth row. Okay, fourth row, fifth row, sixth row. Okay, so now each row is a list. I converted it from a string. Okay, however, I don't need the header file, so I will filter it out. So mapping data equal to mapping data filter lambda row, where row 0 not equal to, or I can do column name not in 0, right? So what this says is the first element of each row. This is the first element of first row, first element of second row, first element of third row, fourth row, and fifth row, and sixth row, right? So these first elements do not have the value column name. If it has column name, then drop that row, keep all other row, and put it in mapping data. So now I'll collect it. So now if you see, the header is gone. I only have the actual data, right? So now coming to this line here, I'm mapping it and I'm converting this row of list into row of dictionary, right? So just copy paste it. And I'll do map RDD formatted, select. Okay, so now if you see, each row is a dictionary, right? And it has one key called as column name and another key called as position, right? So what it did is it took the first element and put it into column name, second and third element into position, fourth element is ignored for now. As I said, these are all, I have not implemented everything, right? So column name and position, each row has those two keys, right? And now each row is a dictionary instead of a list, right? Okay. And what am I returning? So I'm returning it in a Python object, Python list of dictionary, right? So at this point, get column info is returning a Python list of dictionary. It took an RDD, right? Did some manipulation over it and returned the Python list of dictionary. Right? So that Python list of dictionary, where it comes here, goes inside column info. Okay, so now column info. Okay, so now this is a Python object. It is no longer a Spark RDD. Now let's go to the next one. I'm saying format the, okay, so there's another RDD called as formatted data. It takes the base file RDD, right? And on that it uses the map function where on each row, another model function is being called, that is split data from model function. Okay. This particular split data function is called, where in which I'm passing each row of this base file plus the column info. Okay. So every row, if base file has 1000 rows, split data will become 1000 times. Each time the row will be passed, right? That particular row will be passed plus column info. So column info keeps getting passed 1000 times. Okay, you can make this code much better, but much efficient. But for now, this particular thing will be passed 1000 times. Okay, same information, right? So we'll take a sample example. Let me see if I can read a sample first. Okay. This is a good sample, 3 records. So I will push this. One. Hadoop, GFS, put /root /pvm 3700 sample. Yeah. So let me take base file RDD. So instead of Spark, I'll use Spark context itself. sc.text file and input file is sample 3700 txt. Yeah. So now if I read base file dot collect, you'll see that everything is one big string, right? So this is first row, this is second row, and this is third row, right? So I need to now split it in a proper format, right? I need to get this and put it in as a one new row element, this as the next row element, and so on and so forth. Right? So for that, what I'm doing is I've created a function called as raw row, right? So in raw row, what happens is each time this column info is being passed, right? So this is something that is common for all the rows within my RDD, right? And this base file RDD, right? Only difference is, yeah. So this is something that is common. Okay, so I have 3 rows, right? For my base file, if I let's assume that I have 3 rows, right? So this particular map function is called 3 times, right? And each time within that, for each row, I'm calling the split data function. So that means again, this particular function is being called 3 times, right? Each time the current row would be passed, right? For first time, first row would be passed. Second time, second row would be passed. Third time, third row would be passed, right? So on that, with that row information, I'm also passing the column info, which is the list of dictionary at this point, right? So what does the list of dictionary have? It has the column name, position, column name, position. So all the column names for required for that particular raw data is available. Okay. So my input data is like this. Raw row is basically one big list. We have seen it, right? One big string, not one big list. So this is my raw row, correct? So first time the map function gets this information and this entire thing. Okay. So now I will use that information in column info. So what I'm doing is, as I said, column info is a list of dictionary. So I'll use for loop and I will iterate over each element of the dictionary, each element of the list, right? So first dictionary will be item, right? So item column name will be passed on to column name. Start and end position will be taken from the position value, which is nothing but a tuple. And in that tuple, 0th element is the start position. End position is at the first element. So if you see that, you can see it here. Right? So value of position is this, a tuple. First element will be a starting point. Second element will be your ending point. And if you see it's a string, I'm converting that into an integer. Okay, so that there's no confusion there. Okay, and then I'm doing string split. Okay, string indexing. Let me just do some basic Python. Okay. Raw row exe equal to, okay, let's say this is my raw row, right? We have one big string. And my first column is sub ID, right? So I'm putting column name equal to sub ID. And start equal to 1 and equal to 33. Okay. So now I will use the starting and ending position and indexes and remove this particular value. So how do I do that? Right. We have seen string indexing, right? So when I do raw row ex and 1, I think it is 0 here. Start minus 1, right? So start minus 1, which is 0. 1 minus 1 is 0 till 33. Okay. So it will extract this much information, right? And from there, I'm stripping, that is removing all the empty spaces. This much I'm removing. Now, if you see, I'll get the value 7860, right? So this value, I will map it to a new dictionary where the key would be the column name, right? That is sub ID. New data, column name equal to this value. Okay, so this is how my dictionary looks like at the end of first iteration, right? So now my first column is done. First column from the column info is done. I got the value, I put it inside a dictionary. Next, the next dictionary within my column info. What is my next dictionary? Column info dictionary is patient ID, right? So now my column name is patient ID. Go to patient ID. Start is what actually? Start is 34, end is 68. So 34 minus 3 is, I'll do 34. End is 68. And new data column name. Okay. So now when I print new data, okay, this was from earlier execution. This is from my current execution. Oh, my bad, my bad. This is what? 34 minus 1 is 33 to 68. Okay. So now I get patient information. Right. So like that, I will traverse all the column names within my column info one by one. And accordingly, I will split the row value and convert it into a dictionary. Okay. So now at the end of the day, I have a dictionary which will look like this. Sub ID is this, patient ID is this, first name this, last name that, blah, 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 right? My original data will be like this, right? This would be my original data, and the output of this function will look something like this. Okay. So this is what is being returned here to formatted data RDD, and on that I'm calling the save as text file action operation, where it will write it to the output file folder, right? So this is what it is. We will run this. So how are we running this? We have a shell script. Within this shell script, we are doing Spark submit. I told you this is one of the way, right? Where the deployment mode is yarn, right? And I'm saying number of executors, please use 2 executors, and number of executor cores should be at least 1. Memory should be at least 4, and the entire, all these 3 files, right? I put it inside the run.py, model.py, and environment.py. I've put it inside this particular zip file that I'm passing it as py files. And the config file is being passed as the files option, right? And then finally, I'm saying, boss, this is where the actual execution should start from, run.py. And this basically I'm logging it. This is the shell scripting way of logging your output. So whatever output comes from Spark submit goes inside log.txt. Okay. So we have all this sitting in, I'll repartition into a single file. Okay. So here finally, when I get the data, I want to put it in a single partition itself so that there'll be one file. I told you save as text file, each executor will write its own part, right? So if there are 2 parts to this RDD, there'll be 2 part files, right? So I don't want 2 parts files, rather I would only want one single part file. So I'll use repartition and do it. Okay. So now this is, let me remove this and need the name. to this. Okay, so now zip file is available. Now let me put this back. I've got it. So everything is ready. I have the script. I just need to call the shell script and it will automatically start the Spark job, right? And then I'll get the output. Once I can also see what is happening in the logger file. So now let me exit this. Let me go to PBM 3700. And in that, I will go to sh job name. So now I've started I've called the shell script. So log file will get created. Okay. We're still starting. It's still running. Still running. Okay. Looks like it's almost done. Okay. Yeah. So it completed. And there are no errors. So the file should be created. And let's go to HDFS, PBM 3700. So within output, there will be a file, sorry, yeah, with the timestamp. Click on it. If you see, there is one single part file because we did the repartition. Okay. So now let me download this. Okay, so when I click on this, you see that this was the input file, right? with no information. I mean, it's not in a good shape. Now I have an output which has everything. I mean, which has everything that HCSC needs, and the same thing will be done for other files as well from other clients, maybe Cognizant, TCS, whoever it is. Right? So for structured processing, structured data processing, we needed something that could have some sort of a schema to it, could have some, we could add a shape to the data, right? So that is where DataFrame's API and Spark SQL came in. The underlying data structure is DataFrames, right? And it looks very much similar to a MySQL table, okay? It only looks, okay, but in the backend, it is very similar how RDD functions, right? How does RDD functions? It is a resilient distributed data set. It is partitioned, it is sent across different executors, and in those executors, the code is processed. I mean, code is executed one by one. That is transformation and actions, and the new partitions for new RDDs are created, right? Same thing with data frames as well. Whatever we have seen with RDD, how it works in the backend, same exists for data frames as well, right? So data frames will get split into partitions, and on those partitions, transformation action will be performed, and that will result in a new data frames, new partition, right? So there's no change in that. Only thing is how the data frame looks, right, compared to RDD, how it works. I mean, what all data frame brings in extra, right? It is kind of different. So now that we have moved on to DataFrame API and Spark SQL, I think it's time that we also move on to how we create the Spark context object, right? So we should no longer use Spark context because that is not the new way of doing it, right? So the new way of doing it is using the Spark session object. So I'll create a Spark session object itself, right? So this can be used even for RDDs as well as Spark SQL context. But for you to understand how we used to do earlier, what we would do is we would create a Spark context object, right? And on top of that, we would create a Spark SQL context, okay? In which we would pass the Spark context object. Okay. On this SQL context, all DataFrame API and Spark SQL we can use. Okay. So I keep saying DataFrame API and Spark SQL. So what is the difference actually? Okay. So Spark has for data frames, it has given us two ways to use it. Okay. So you can create a data frame using a function kind of function call kind of way, right? So you will have API calls like this, read.csv or Spark create data frame, Spark.read JSON, Spark.read Parquet, right? So that if you look, right, it is like calling a function, right? So that is what we did in even RDDs as well. We used to keep calling functions. But then the requirement came that was even database developers are coming into Spark, and they're not well versed with how function and what is a function call, the Pythonic way of doing it, right? So for them, what they did is, okay, fine, let's not, if you don't want to use syntaxes like this, at least, I mean, throughout your program, at least you just read something or read the input data frame or the input data and convert it into some temporary table. And then on that temporary table, you do some analysis. Okay. So let me just, okay. So on that table, at least you try to read it and convert it into a Spark temporary view. And then onwards, you can use any SQL that you have done in you used in MySQL or MS SQL. Everything is viable, right? So that is why we call Spark DataFrame API and Spark SQL. Okay. Ultimately, the output for both, ultimately the data structure used in both of them is a data frame. Okay. Only difference is you don't have to completely. Just give me a minute. Yeah. So ultimately, at the end of the day, both are having the data structure, data frames. under it. I mean, the actual data frames, I mean, the actual data structure used by them is data frame. Only thing is the approach in which they are going to, approach in which we have to process the data, right? So with Spark SQL, most of your code will be written in SQL, right? Something like this, right? However, if I want to do it in a Spark data frame, I'll have to call function. So same thing, right? Same thing I have to do. Spark.select. Sorry. Yeah. So if you see, two ways of doing the same thing, right? There's the Spark SQL way of doing it. There's the Spark data frame API way of doing it, right? So ultimately, the output will always be a data frame, right? And the actual data structure is a data frame. But how we use it? Spark SQL is a convenience for people who are coming from a database background. They don't have to use much of Pyspark code, right? Only thing is, while reading it, they may have to use some Spark code, right? But once they've ingested it, they can keep using the Spark SQL for their needs and purposes, right? I hope you understood what is the difference. So we will focus more on the data frame API, right? Because SQL everybody knows. I'm not going into that part. We'll see one by one all the functions within the Spark data frame APIs. Okay. So Spark SQL is again built on Hive SQL and your normal SQL, right? Hive SQL is again built on top of MySQL. Right? So MySQL server, whatever the SQL language that you're using, on top of that only Hive has built its own SQL. Okay. So whatever you have done in MySQL should work in Spark SQL. All the syntaxes, everything should work. Okay. So MS SQL, some of them you may not work. Like in MS SQL, we use top and everything to see first n number of rows. That won't work because in Spark it is limit, right? So select star from table, limit 1 or limit 100, limit 200, limit and offsets work. Okay. Yeah, so Spark SQL is basically for structured data processing. That means you have a data which has metadata, like what is what are the columns for this particular data. For each column, what is the data type, whether it is nullable, not nullable. All these are meta information. So such kind of data is called as structured data, right? And for structured data, Spark SQL is the best way to process it. Need for Spark SQL, as I said, there are problems with RDD when it comes to working with data structures, trying to maintain the metadata information for your existing data, right? Last time we saw that it was not we were not able to give some column names. We are not able to select it directly from column names and everything, right? So there are a couple of ETL tools available. Okay, one is Hive, which is your at this point a fully fledged data warehouse. Okay, so there's a time when Hive was introduced, it was nothing but an interface for Hadoop's MapReduce, right? So people who do not know MapReduce coding could go to Hive and work with it, right? But later on, Hive was converted into full-fledged data warehousing system, right? and the underlying engine is no longer MapReduce. It is either Tez or Spark itself. Okay. On the other hand, Apache Impala is, again, to be honest, it is it's a product from, I told you that when we did the first session on Hadoop, there are multiple distributors, right? Cloudera, Hortonworks, and MapR, right? So they were the initial distributors of Hadoop, and they had built something extra for their users, right? So Apache Impala was built by Cloudera, okay? So it was a complete copy or like a extension of Hive, right? But it had some extra features on top of Hive. Okay. So it is kind of like a data warehousing tool itself. Okay, don't go with the slides. I mean, they have given some not so correct information, right? So Impala is basically a copy of Hive. So even when you do Cloudera certification, right, you will be end up writing into Impala and not Hive, because that is their default data warehousing system, right? And Spark SQL is basically used by data engineers and data scientists to do ETL work, right? All your ETL work can be done using the Spark SQL. I don't know why we even compare these three. They're three different things. Okay. Yeah, one thing is, as I said, one can actually use SQL queries in your Spark programs. There's nothing special that you have to learn in terms of SQL, right? Whatever you have learned in MySQL works here as well, right? And it can easily connect to Hive as well. Okay, so I can directly query Hive table from Spark once Hive is integrated to Hive is integrated with Spark. I can directly query from Hive. Okay. And we have one more thing in in Spark core. With RDD, we saw that we can only read from text file or flat files with some delimiters, right? But in Spark SQL case, the number of sources that we can read the data from is humongous, right? We can read from a CSV file, JSON, Parquet, Avro, text, XML. We can even directly connect to a remote JDBC system, RDBMS system, like an MS SQL server or MySQL server or some Postgres server, whatever it is, and directly read the data and convert it into a data frame, right? So that is how many sources exist. Okay, the number of sources is humongous. Okay, compared to RDD, it is nothing, right? And compared to RDD, it has something called as a catalyst optimizer. Okay, so catalyst optimizer and lazy evaluation, that is one of the properties of Spark, works very well and creates a very efficient way of reading the code, right? For example, here, let's go with this. Okay. So let's say my boss comes and says, yeah, see, we have this T20 cricket data, right? Read it. And first thing is, we'll not consider whatever dashboard that we are building for ESPN Cricket Info. Our client has come back and said that we are not going to consider anybody who has scored less than 2000 runs for any sort of, creating a dashboard, like number of highest number of centuries scored or highest number of balls faced. So for all these calculations, we are not using players who have not scored more than 2000 runs, right? So remove them. So that is why what we do is, after reading it, we are filtering it with where condition and saying that where runs at greater than 2000, only those players you consider, right? So, but for us, it is our normal way of coding. But in the backend, we are building in efficiency, right? Because where is a transformation function? Again, just like in RDD, here also we have transformation and action function, right? So when I do df1.show, show is again similar to your Pyspark RDD collect, right? Collect is an action operation which is displaying all the data of the RDD, right? Show is also a collect operation that is displaying all the data of a data frame, right? So when I call this collect operation, because of lazy evaluation at this till here, when I do this, it doesn't execute anything because I'm not called in any action operation. But as soon as I call the action operation, it will start from the beginning, right? But what happens now is I have a SQL optimizer, okay, that comes with, it's called as an catalyst optimizer, okay. Yeah. So it is called as a catalyst optimizer, which takes my actual SQL Spark DataFrame API calls, converts it into SQL, and it tries to build up a plan, okay, a physical plan, logical plan, and everything, right? Sorry, logical plan. And then finally, it comes to a conclusion that, okay, these two operations can be clubbed together, okay. I don't have to read the entire file and then filter out where runs is greater than 2000. Rather, while reading itself, I will take uh, the data where, what do you say, where I will not read the uh, rest of the files. Okay. Best way to show is using the virtual box. There you can see the data being called. System CTL tables. Okay, let me go to slave one, $home, $spark home, then spark down. Yes. For that, let me check SSH slave one and student performance.csv. So what are the columns that I have? Gender, and how does the gender look? Female. Okay, fine. So I will read the student dot c. Let me see if that file exists. Okay, that's actually corrupted here. So I have to read. I have to put the file again. Let me put the file again. One. /csv. Right, this. Okay, so now let me read the file. df equal to spark.csv slash spark.csv, and within that we are calling the file student perform csv header equal to true. Okay, so now if you see, when I did explain in the physical plan, it says file CSV, file scan, right? So it did not do the entire file scan. Before doing the file scan itself, it filtered it out based on the gender column, right? So this way, I don't have to read the entire file. I'm just, I can club few of the functions together and improve my performance. So this is what my Catalyst Optimizer does. It takes in all the transformation and action operations, right, together, and it checks, okay, where and all I can make the changes, right? He's saying that read the file and then filter the data on that file using the gender column, right? Rather than doing it in 2 steps, let me do it in a single step, right? Let me scan the file, but based on the filter where gender equal to female. So that way I don't have to read the whole file at all. Okay. Let me see how. Six. Sorry, I need to show here. So if you see here, right, it only read the 39 records, even though student performance.csv has millions of records. But since I used the where clause and the Spark Catalyst Optimizer, what do you say, combined those two operations together, instead of having to read all the 1 million records and from there filtering out 39 records, it did it right at the beginning itself, right? So that is what your Catalyst Optimizer helps you do. Okay. Let me now shut this down. So in Spark data frames, API and SQL, the entry point is your Spark SQL context object, right? In Spark core, the entry point was Spark context, right? But as I said, these are all old concepts. In today's time, for both of them, the entry point is Spark session object. If you don't create, the creation of a Spark context object, SQL context object, they're all old methods, okay? Oh, there's no record where mail is there. Oh, it's possible that. Thank you. see it right around 500,000 records, right? Because it did not find that filter. Okay, it had to read all the 49,000 records, 500,000 records.
Let's have a quick quiz question, guys, and the question is, a variety of programming languages can be used with the Pyspark framework, such as Dash and R. And your options are Scala, Java, Python, or all of the above. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.
Yeah, 80,000, 805,000 are female, 206,000 are male. Why did I? Oh, I get it. My code was wrong. Okay. So what I did was I said I already filtered it on female. Okay. And I put it in the same DF name. Okay. So when I read it, it was under DF. Okay. The name of the DF itself was DataFrame was DF. And then on that DF, I filtered it on female and put it again in the DF. Okay. And then in that DF, I'm trying to search if there's any gender where it is male, right? So it is kind of correct only. So here, if you see, I'm searching whether gender is male, but at this point, DF only has female data, right? So that is why it did not show. But now we can do directly here. So, it only read 44 records. Let me SQL. This last one. The number of rows is 44. Because see, one more thing. The reason why it is reading so less rows is I'm only showing the top 20 rows. So I only require top 20 rows. If I've done 300,000, it would be different. Yeah, my bad. It is somewhat different than collect. Okay. Collect would show me all the data, like by default. When I do collect, it will show me all the rows within the RDD. But for show, there's a default number of rows it will show. It will only show me the first 20 rows. So if I have to override it, I have to specify the number of rows that I want to see. Driver out of memory error. Let me see. Okay, what is the another out of memory? Okay. So this is what driver out of memory error looks like. So I try to bring all the 200,000 rows to the driver's RAM and then show it to me. But unfortunately, it won't. I'm not able to see it. So if not 3,000, let's make 300. Okay. it showed me 300 rows. Now when I click on it, upwards of 611 records. Okay. So it was reading 611 records. The reason is it will read one entire partition, right? Or so if you see number of files, number of rows it read, yeah. So it read an entire partition, and that partition may have around 600 rows or something, right? And from there it filtered 301 rows out of there. That is including the header, right? One is for header, 300 is the this. Okay. So that is what optimizer does, right? So I don't end up reading the entire file. I don't end up reading 1 million records. I'm only reading 611 records, and then I'm filtering out 301 records and then showing it to you. Okay? So that is what SQL optimizer does. That is something missing in Spark core, right? So that is another advantage of why we should be using Spark DataFrame APIs, right? DataFrame APIs or Spark SQL. Okay. So if you see here, I use Spark SQL only, right? I did select star from student and blah, 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 right? If I wanted to use DataFrame APIs, I had to do df1 equal to now df1 dot select star. Okay. I had to do this. It is same as doing what I did using the SQL. Okay, right. Yeah. So this, right? So what happens? This data frame has the data where all the mail records exist, right? So when I do df select star, it will select from that particular data frame. So the syntax is I went exit. So the syntax will be like this: df select. So whatever whatever API functions you have to call has to be called on a data frame name only. So you have to first create the data frame. Data frames, okay, data frame functions. As I said, data frame is very similar to your relational table or your MySQL table, right? It has a column, it has rows, it has for each column, it has a metadata like what is name, what is whether it's nullable, what is the data type, and all the stuff, right? Just like how it is there in your MySQL database. Only difference is in your MySQL server, it may be in a single place, but a data frame, just like RDD, will be split into partitions, right? And then on those individual partitions, it will be executed. Right? So all the properties that we saw with RDDs exist with data frames as well. RDDs are also immutable. Data frame is also immutable. RDDs also have lazy evaluation. That means it will only calculate once action operation is given. Data frames also does that. Data frame is also distributed. It is partitioned and sent across different executors. RDD is also distributed, right? The same thing in the backend concept properties are similar to what we learned in RDDs, right? Only thing is, as I said, a couple of things. The functions are very different from RDDs. Main thing is it can read and write to different sources, read from different sources, write from different sources, right? So as I said, there are many. What you see here is just a small amount of number of sources mentioned here. I don't think there is any source which Spark cannot directly connect to Spark SQL context. Spark SQL cannot directly connect to. I don't think there is any source in today's time. Okay, if you want to read from API also, Spark has a direct way to read it. I think Spark 3.0 has, if I'm not wrong. That also they've done. Spark 3.0 read from API. Somewhere I was seeing last time that they actually read from an API. Yeah, so if you see here, directly from API, you can read and convert it to a data frame. So that is also possible in today's time. Okay, so that is how that's how advanced Spark data frame API is, right? It can read from n number of sources and write to n number of sources directly. Right? So that is again plus point in terms of RDDs, right? RDDs cannot do that. Data frames can, right? So how do we create a data frames? Okay, I will go into that. There are a couple of transformation functions available, right? Yeah. Before we go into the transformation function select, we will see what are all the data frame transformation functions available to us, right? First, let me. What was this? Yeah. What I was saying was, yeah. So there are a couple of ways to create a data frame. Okay. One is to use the Spark read function. So Spark read function gives me a way to read from n different sources. Okay. So the older way of reading from, let's say, CSV file was, let me copy this, data format and CSV option. Load. Yeah. XML option header option. Tag. XML. We also have QUT parquet JSON. JSON and what else? Same thing I can do with JSON as well. And what else? From JDBC also, we have read JDBC. Within JDBC, okay, constructor, DataFrame URL, blah blah blah. Okay. Value of user, okay, number of addition predicates, okay, parameters, column, table name, all this stuff, yeah. It'll have something like URL equal to this, and then properties like this, blah blah blah, and what else? So property called as table and URL. Okay. And what else? From head table. There's an old way of doing it. Stable. Okay. And this, okay, so these are some of the examples how you can read from n different kind of sources and create a data frame, right? Suppose, let's say you do not have any data source, right? So in Spark RDD, what there were two functions. One was read from what do you say, Spark context.text file, and other was Spark context.parallelize, right? So here we have these many, and there are more ways of reading from different number of sources. But if any of those sources don't exist, you have to create our data frame itself from scratch. There is no input file available to you, right? Then you can use Spark.create data frame function. Okay. And within create data frame function, if you look at what it takes is, either a Python list of something or an RDD or a pandas data frame. Okay, so pandas is the original Python library that actually came up with the data frame concept. Only thing is it works on a single machine, but here in Spark it is distributed computing. So obviously data frames are being processed in multiple executors across the clusters, right? So otherwise, pandas data frame also, all the functions in pandas data frame is very similar to whatever you have done in Spark data frame, right? So that is another advantage for people who are coming from Python data science background, because they've already learned pandas data frame, right? So it can take an RDD or a list or a pandas data frame, right? So I do not have the source input file or something. I can just create my own data frame using the create data frame name. Praveen. So Parquet and Avro are the two file systems, file types, which are commonly used because they hold the schema itself, schema with it. That means, see, CSV doesn't have a schema. Okay, meaning you see that there are rows and columns, but you do not know that first column is a string type, second column is a integer type. That is not defined, right? So when I see a CSV file, right? Yeah. So when I see the CSV file, there's no place where I can give that ID is an integer column, gender is a string column. Everything by default is a string, correct? There is no data type mentioned in CSV. However, even in others also, JSON, XML, all other formats, same thing. There is no schema defined by that particular file type, right? We may have to define it in Spark when we read it, right? Otherwise, they will use whatever default schema is there, they will use it, right? So that is the problem with them. And also the file sizes, right? CSV occupies a huge amount. It is like what 1 million records is occupying 185 MB, which is huge compared to how much data it is holding, right? So Parquet and Avro are two such files that not only has the schema with it, but is also highly compressed. Okay, Parquet is the highest compression available. So the same 1 million records in CSV can be 10 KB in Parquet and 50 KB in Avro, right? So that's how compressed it will be. This is 185 MB, this is 10 KB, this is 50 KB, right? So how internally it is stored is, I show you how Avro is stored. So in the Avro file, let's say this is the Avro file, okay? So there will be a space where it will have something like the schema, column name, ID, type, integer, value, sorry, not type, and nullable, yes. Then next column, name is student name, student. So like that, it will have the actual schema in the top, and after that, it will have the data. It will have the data for row one equal to value for name will be Praveen, and then sorry, ID is once. Blah blah blah. Then I'll have row 2 So this is how actually the Avro file will look like. Okay, it may not have row 1 and row 2. Okay, I'm just assuming it. Generally, it will have just like this. Yeah. Okay. So data for each row will be separately given. Okay. So when I read the Avro file, immediately all the metadata information is applied on the data and then read. Okay. So same thing with Parquet. It also has a schema and everything stored within it. Okay, but only thing is it is highly compressed. You cannot directly read a Parquet file. If you directly open a Parquet file, everything will be garbage. You won't be able to see the data. Okay, so those are the newer file formats, which is heavily used in big data. Okay, most likely your source files will either be in these two. Okay, yeah, yeah. So if you don't have any of these sources, you want to create it, then you can go with create data frame, right? So here what I've done is, okay, I'll show this. Get dot show. Let's see. It took both rows and converted into a data frame, right? So we can also do that with an RDD. Let's say I had an RDD earlier, somewhere RDD1 equal to spark dot spark context parallelize 3, 4, 5. Let's say I created a single column records, right? I just need to pass RDD and to convert it into data frame. Okay. Cannot infer integer type. Okay. So let's make the string. So it's a data frame from an RDD. It should actually take in. Let's go with their own implementation. Okay. From an RDD, you can create a data frame as well. Right. So these are the options that are available for you to create a data frame. These many functions exist. Right. So once you have created a data frame, right? So DF cricket is a data frame. I can use all the data frame transformation and action operation on that particular data frame, right? So first one is select. So what does select do? just like in your SQL, you want to select few columns, you can use the select command. Right. One more thing before we go into that, Spark SQL has one other amazing thing. It is called as inferring schema, right? So if you see any of these functions, when I'm reading from the file, I'm not giving any schema, or there is an option to give a schema. Okay, so to define a user defined schema and then put all the data to fit into that particular schema, that is possible, right? But when I don't do when I just read it, and when I print the schema, so there's a function called as print schema. It is neither a transformation operation or an action operation. It is just a utility function. Okay. So now if you see here, right, it is assuming that these rows are all string, but I never mentioned any schema, not a CSV is a file type which actually gives a way to read the schema, right? So how does it do it? Spark has something called as inferring schema option. When you do not provide the schema, it will look at the first row of this file and it will infer, okay, fine, this is the value. So it's a string value. I'll take it as a string, right? So it will look at the first row and decide. So make sure that if you're not providing any schema, that file is having the correct values, because if it has null, then that column will become null type, right? So that is why you need to make sure that either you provide a schema or you don't, right? So how do we provide a schema? So in Python, Pyspark, sorry. Pyspark .sql dot types import star. Okay. User defined schema equal to this. I would say I should choose thing. It's a lot of columns. Okay. So match as integer type, right? Innings also integer type. Not out is also not. Runs as integer. Average and all strike rate, they are all boolean. Hundreds is integer type, integer type, integer type, integer type, integer type. Okay, so now instead of this list, there is true schema equal to user schema. Is that correct? User schema. The module Pyspark. ID is not defined. Okay, so now whatever we have defined, it has come. ID is an integer and all those blah, blah, blah. Right. So this is how we define a user defined schema. Okay. So within Pyspark SQL types, there is a struct type, struct field type, integer type, string type, Boolean type, decimal type, and all the kinds of data types are available inside this particular Pyspark module. Okay. Called as types. We have to import it. Right. First thing we have to do that. Right? So struct type is basically trying to say that, boss, this is how my table will look like, and struct field will say, boss, this is the information about each column. Okay, so this is the column name, this is the data type of that column, and it is nullable. Okay, so if you hover over it, struct field, a field in struct type, right? String name, a parameter name, which is nothing but name of the field, data type of the field, nullable or not, right? Same thing if you look at struct type. Struct type consists of a list of struct field, right? This is a data type representing a row. So in order to define a schema, we need to have struct type. Within that, we need to define a list. Within that list, you have to give all the row, you have to define all the rows of that particular file or whatever the input data source is, right? So when you do this, now it will automatically, it will not go for inferring the schema. It will not look at the first row and decide whether each column is this or that. Rather, it will work with this particular schema and apply the schema on that source file and then convert it into a data frame. We'll see the other transformations within DataFrame APIs, right? So the first transformation is select. Okay, so let me go back and remove all this. Okay, so select command is basically selecting all the columns that is equivalent to your select column 1, column 2 from table name. That is the equivalent SQL, right? But in a DataFrame API, we have df say df1 equal to df cricket. Oh, I have not loaded the file. Basically, I have not loaded anything. Yeah, now let's select. Okay. So first we read the cricketers file, we gave the schema and put it in a data frame called as cricket. I told you that print schema is a function. It's neither transformation or action. It will show you the schema of the data frame, right? So what is the column? What is the data type, whether it's nullable or not. Right? The third is an action operation called as show. Show is equivalent to collect in RDD. RDD at collect, data frame has show, right? So it will display the data frame. So if you see here, it is displaying the data frame, right? So now the next transformation function is select. Okay, so we take the data frame name, okay, and do select. Within select, we can give column names, right? So let's just I just want to see ID and player name. Is it player name? Yeah, player name. Then now my df1 has only ID and player name. So this data frame has only two columns, ID and player name, right? me switch this off. Okay. So we can either write select command like select a function like this, or we can do it in a couple of different ways. We can do df cricket. We can use the data frame name dot id column name and df name dot column name. Okay, so this is another way. Third way is to import column function from Pyspark .sql functions import column. Okay, and once you import it, you can do column id okay. So basically this all the three notations may work for any of the functions, but you have to check. Okay, I'm not saying that all the transformation functions will you can use all the three notations. That is either using column function or using the data frame name dot and dot operator or just the column name. Okay, so you have to check which one works, which doesn't work. But for select, all the three approaches work. Okay. Okay. So any of these approaches will work with select. Okay. So, but for other transformation, you need to check which whether using column will work or just the data frame name dot operator, that approach will work, or just the column name will work. Okay. So next transformation is filter function. But first, let me do one thing. I'm just going to select all. Okay. And in my df2, I'm going to say filter everyone who's from India, right? So df I have not calculated the year, correct? Okay. So before filter, we'll go with mutate. Okay. So the next transformation function is mutate, right? So mutate is basically with column. Okay. So that's the with column function. Why it is calling mutate is it changes the data frame in the sense it adds something to the data frame, right? So we add a new column using the with column function. Okay. With column. And we will call it as country. Okay, and how do I define country is Celestia def1 dot player name comma 2, 3, 4, 5, 6. Let's see if this works or not. Sebastian is not defined. What I can do is string. 1, 2, 3, A, N, D, I, A, 5. Substring is not defined. Yeah, okay. So now I do get India, but others are not that correct, right? What else? What other logic can I do? What we'll do is we'll create a UDF. That's a better approach. Yeah, so here I'll tell you what is a UDF, user defined function, right? So if you see any function that is by default given by Pyspark or Python may not work, right? The logic may be complex. So what we can do is we can create our own function, and with the with column mutate transformation, we will pass that particular column and get the result from the UDF. Okay. So what with column does is, so here I'm creating a new column called as country, and then the logic for the value of country. Sometimes it can be very simple. For example, let's say they may tell you that, okay, create a country for now with null values or zero values. Later on, we will take care of it. So what we can do is we can do lit. So lit is a function that will copy the same value for all the rows for this particular column. So it will copy value 0 for all the rows for the column country. Okay. So we can do that, but that's a very simple logic. Or they may say that, okay, country may be df1 dot runs into df1 dot strike rate. Okay, some not countries. Let's say runs into strike rate is what let's say MVP points. Okay, but there's a very simple logic, right? SR df1 doesn't have SR. Show SR. Okay. Okay. Yeah, df2. Yeah. So let's say I calculated this particular MVP. Okay, so they say, okay, boss, we need to create a new column called as MVP, and this is the logic, right? So these logic is very simple to do. But for countries, you saw that the logic was very difficult. So let us create that column using UDF. Okay. So let me create not here. Here. Def country calculations. Take player name. Okay. Then on that player name, so I get a player name. Okay, on that player name, let me do list of what can I say? Post split list. Okay, let's connect that. Then player name, which is a string, that's split based on this. Okay, I'll take directly as a country. So player name, basically player name column is always a string, correct? We have seen that it's a string. Okay, so I'm going to split on this. So this will be list element 0. This will be list element 1. Okay, so I will take list element 1. But what if it doesn't have this? Right? Okay, whatever. Let's see if I get any error. And after this, I will split on this again. So I got this much, and I'm going to split on this part on this. So this will become 0. Okay, 0. This should be good enough. Hoping that it is. Let us see if we get an error. Return. I'm pretty sure I will get an error because there may be columns where it doesn't have any of this, right? Okay. So first thing is we define a normal Python function. Okay. Now we need to tell Pyspark that you convert this particular normal Python function into a user defined function. Okay. So we need to register it. So first thing we'll call it as country cal UDF equal to UDF. And I'm going to call country call name of the function and the return type, which is string type. String type I've already imported using types, so I don't have to import it again. So what we are saying is, boss, you take this Python normal Python function, convert it into a UDF, and the return type is string type, and we are going to call this UDF as country cal UDF. Right? So all I need to do is now pass this function for the player name, right? df1 dot player name. So player name will be passed to this UDF function, right? And this UDF function will calculate country and return country value, which will go to the column country value for each row, right? So this way, hoping that we solve the previous problem. Yeah, luckily no error. And hopefully, yes. Okay. So now we have a country column. Okay. So next, then we can use the filter function. So df3 equal to df2 dot where country. Let's say my boss comes and says we want to only show stats for Indian players, right? So okay, and now I do df3. So now I'll get all the Indian player names, right? Virat Kohli, Irfan Pathan, Ashwin, all of this. Okay. So here we use two transformation. One is mutate with that is with column. Next is with the where clause. Okay. So there is the here you may see that we are not using sorry. We should have used filter, right? So there is no difference between where and filter. Filter was the older way of doing it. Okay, I could have done the same thing with filter as well. df2.filter, and I can just copy paste whatever here, and it will still work. There is absolutely no difference. The only reason why they brought, I told you, in Spark DataFrame APIs, they try to match what we do in SQL, right? So in SQL we have where clause, but in here we had filter earlier, right? So that's why they decided, okay, why not change the name to where? But because people have already developed using filter, we need to maintain backward compatibility. That is the only reason why filter exists. Okay. Otherwise, both are same. If you hover over it, in fact, you will see the example saying that where is an alias for filter. Okay. And you see the definition also, it is showing filter only. So there is no performance improvement, nothing. Only thing is it makes it more sensible. People reading it for the first time, people who are coming from an SQL background, for them, it will become easier to understand the code. Okay. So that was about filter transformation. And we saw with column, which is our mutate transformation. And we also saw how to create a UDF, right? So this is very important because there'll be a lot of times where you're expected to create a column, a new column for the data frame, and the logic is very complex, right? So that point in time, we'll definitely be working with UDF. So any questions in any of the three, UDF, with column, where?
Let's have a quick quiz question, guys, and the question is, the primary machine learning API for Spark is now the dash-based API, and your options are RDD, dataset, DataFrame, or all of the above. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.
Player name, runs, country. So I only need these many. Okay. So this is equivalent to select ID, player name, runs, country. Let's say the table name was DF2. Okay, I'm just giving an example where country equal to India. Okay, so this is your MySQL equivalent query. Okay, okay. The next transformation, that is mutate, summarize. Okay, summarize is nothing but your group by clause, right? So let's say my boss comes and says, show me number of players per country, right? I want to display that data. So what we will do is, let me remove this. DF2 has country calculation done, right? So DF count by country equal to DF2 dot group by column name, which is country. Okay, so at this point, this particular, when I use group by, the output is basically something called as a group data frame. Okay, I'm calling it GDF. Okay, so on this GDF, it is not a normal GDF, so I cannot use action operation and transformation operations what I've used, right? For example, I cannot do GDF.show. It will say that group data frame does not have attribute show. Okay, so now if you see, yeah, group data object has no attribute show, right? So we need to convert it back to your normal data frame, right? You would have seen this in SQL also. Can you do this in SQL? Let's select star from DF2 group by country. You run this, it will give you an error saying that some of the columns are not part of your group by clause, right? Only the group by clause can be whatever column has been mentioned in group by clause, that only will be eligible for display, right? Same thing here. So now at this point, you're trying to say select star from DF2 group by on country, right? So it's saying you cannot display that, right? So you have to apply some sort of an aggregation on top of that. And I'm going to say let's say on runs, I want to do total. Okay, so the ask is get the total number of players per country and total number of runs scored by a country, right? So if India, I have to sum up all the for all the players, I need to sum up the runs. So the equivalent query is count star and sum of runs and then the country name. Okay, so this is what is the ask, right? So get me all the countries, right? And against that countries, I need to know total number of player, total, and against that country, I need to know what is the total runs scored by the particular team, right? So that is the ask. So what I've done is on the group by, in order for this to be able to convert into a normal data frame, df country, okay, I have to use the ag function. Okay, so in this ag function, we have to pass a dictionary. Okay, so this particular ag function will only work with group data. Okay, so unless you do not have group by, this aggregation will not work. Same like in MySQL, if I just remove this group by condition, you'll get an error saying that data is not grouped, right? Same thing. So this is a special function that only works with group data. Right? So once you have used group by, use ag. Within that, you give a dictionary, and you can give for multiple columns what are all aggregations that you want to perform. Right? So I want to perform on the star, I want to perform count. Then I have to give star and then count. For the column runs, I'm going to do sum. So I have to give sum. Max runs, if you want to see, or max hundreds, let's say. Column name is 100, if I'm not wrong. Column name is 100. Let me just see. df2.show. Yeah. So on column 100, let's say I want to do max. So okay. So now if you see, country is this, max number of hundreds is this, total number of players is this, total run scored is this. Okay, so we have achieved whatever was our objective, right? But we'll come back to this again, because after group by we need to do order. Okay, so anyway, it's not ordered as at this point. Okay, so we have achieved the whatever goal our goal was, right? Whatever our boss command, whatever problem statement he has given, we have done it, right? So let's say you want to show only teams which have scored more than this particular number of runs, right? Where sum of runs greater than, let's keep some minimum here, so that we get genuine teams. So for now, we'll remove this. Okay. So if this is clear, we'll go to the next one, which is order, arrange. Yeah, sort or order. So again, same thing, sort and order. Earlier, the older function name was sort. Newer function name is order by. That's it. Okay. So even when you do order by and you hover over it, it will give you examples of all sort by only. So if you see, the example they're giving is sort, because it's an alias. Even the definition is saying sort. Just like where class and filter, where function and filter function, same thing. There is absolutely no difference between order by and sort. Okay, but we'll go with the order by because it is more equivalent to your string columns. Okay, I mean more equivalent to your SQL, right? So this is equivalent to order by. We will say max hundreds. I want to Oh, here I have not done whatever it is, max 100 in descending. Okay. So for that, we will give a column name, max 100, and order by. Okay, we'll use the other notation because it is easier to give descending or ascending, but there's a way to do that without having to do it. Yeah, DSC. Yeah. So function, where's function? Okay, DSC and sorry, I don't know why I did this. Okay, so now, oh, India is only 400. That's the highest. Okay, fine. So I did order by. Within that, I've given called the descending order function, and then I passed the column name. There's another way to do the same thing. We'll keep this aside. Stop this. We'll call the df notation. If you remember, we can use the df name dot max 100. The reason is max 100 is kind of a function, right? And 100 is the number. That's why I didn't want to take. I think this will work. So sometimes you may have column names that are like this, right? Which may be like Python function name, and it may be an integer and all those stuff, right? So in that case, instead of dot operator, use the what do you say, brackets, square brackets, okay? By and then do descending. Okay, so this will also work. If the column name was simpler one, like if I want to do it based on country, I can use the dot operator again and then do country, descending, and then it is setting it based on the country. Okay, hope this is clear, right? Just replace order by with sort and you'll have the old approach. Okay, just do sort, it will be old approach. No difference with any performance, any syntax, anything. Everything, whatever works in order by works in sort, whatever works in sort works with order by. It is like an alias, right? Okay, so next comes join. Okay, so if let's say you have two data frame and you want to do a join on that, you can do that. What is the use case for join here? Let me think. First, let me replace this. Okay. What we can do is, I'm thinking of a scenario where we need to join, right? Okay, what I can do is I'll create a country-wise data set. Okay, country data, and I'm going to join with the original df2 based on country, and yeah, I'll just show the total number of players, even though it is for example, the ask is I'm going to show Virat Kohli and he plays for India. He has scored this many runs. I want to show how many players are there in his team, right? So for that, I will have to join the country data with the original df2, right? So I will take join df equal to df2 dot join with country data. So this is kind of like a inner join with some self, right? Because the entire thing is one table only. Everything has been derived from the same table only. But at this point, you just consider that there are two different tables. Okay, it becomes easier. Country data, how do you want to join? And I'm going to say, based on what you want to join, right? So df2 dot country, or either I can give it like this, equal to country data dot country. So this is your on condition, right? So join these two tables, these two data frames on country column from df2 and country column from country data, right? Or you can do, since both the column names are same on both the sides, you can just remove this and just replace it with country. Okay. And let's say if you have multiple multiple conditions, right? So country equal to country name, let's say 100 equal to df2 dot 100 equal to this won't work, 100 equal to country data 100, right? Equal to. So I can have multiple. So I have to put this inside the list, the conditions. So if you see, it's a list. Within that, I have to give comma separated conditions. So this is one on condition, this one joining condition, this one joining condition. Okay. And that is when you need to use this kind of notation when the column names are different, right? But in this case, column names are same, right? So I can give country comma 100. I mean 100 is not common because this column name is called as max 100, whereas df2 has 100. So this will not work, but I'm just giving an example. If there were both sides the column names were same, you can just put it like this, right? So now let me not just do that. Okay, so join on country, and how do we want to join, right? So we know the different kinds of join: right join, left join, inner join, right? So how do you want to do it? I am going to do it inner join, and then on this join df, I'm going to show inner is not defined. Sorry, I need to use string. Okay, so now if you see for Virat Kohli, okay, I took the country data and joined it with it. Okay, so these three columns came from there. Next transformation, which is, I mean, this is basically non-equijoins. If you don't have any equivalent condition, you can put non-equivalent conditions also, and it will automatically work accordingly. Okay. Yeah. So the next function is union. So here there's a bit difference. Okay. So let's say why I want to do union here. I'm just going to take some random data. Okay. So df1 and df2. Yeah, I'll show you the difference. Yeah. Let's say you have two data frames and you want to do union between them. That means you want to horizontally join both of them, right? So then you can use the union function, and we can give the other data frame. Okay, then you can do show. Okay, so if you do this, first thing is you need to remember that both sides, the number of columns, both the data frames, the number of columns should be same, or else you'll get an error saying that right hand side has this many columns, left hand side has this many columns. Now you see, yeah, so the error is union can only be performed on tables with the same number of columns, but the first table has 17 columns and the second table has 19 columns, right? So that is the reason why when we use, I mean, this is same with even SQL also. If you do not have the same number of columns within the table, you'll get an error. But how can we now fix this? Okay, so there is one function called as columns for a particular DF. For example, when I do df1.columns, it creates a list. Okay, it returns a list. Okay, when I do this, so you can use that list and we can put it in select. Yeah, so this is one more. This is a third approach. Okay, so let's say you have a list of columns and you want to say, use it in select command. You just put it in a list and use it in select command. Okay, so that way only those columns will be selected. So now what I did is I took the df1 columns, the data frame 1 columns, selected all the columns from data frame 1. Okay, and from data frame 2, I only selected all the columns that are there in df1, right? I know that df2 has similar columns. Apart from that, it has MVP, points, and country, which is extra. So it will drop those because I'm only selecting the columns that is there in df1. Hope you understood this, right? So this is one way of fixing it, making sure that there's a column list that is same, right? So now if you see, it worked. Okay, but it should have given me double, right? Virat Kohli is there in both df1 and df2, but you don't see it here. The reason is union will only keep one single copy. If everything, all the column values for a particular row is same between df1 row and the df2 row, it will only keep one of the copy. Okay, so earlier they had union all. This would give you the duplicates. Let me do where e equal to 0. What? Okay, their name. Yeah, so if you see, both of them got copied, right? But if I do union, it will only keep one single copy. Oh, they changed it. That is why they depreciated it. Okay, sorry, my bad. So union does the same, does carry the copy itself. I think earlier they were separate. Okay, that is why union all is depreciated. If you run it in your cluster, you'll get that union all is depreciated. Okay, now I know why. Union already has it. So how do we then now drop the duplicates? So there is another function called as drop duplicates. This will drop any row that is completely same. That means all the columns are same, column values are same. So it will drop all those duplicates and you'll get only one single copy. Okay, so that is union. Okay, so one other thing is, let's say there may be a df2, right? df2 may not have player name in the third place. Okay, so first of all, yeah, so df2 may not have second column as player name. Player name may be the first column, id may be a second column, whereas df1 has id as the first column, player name as the second column. So in that case, if I do union, it will still do union, but it won't match the columns. ID of df1 will be, union with player name of df2, right? So that will create a lot of problems. So they came up with a new function called as union by name, right? So union by name will make sure that all the columns are ID column in df1 is union with ID column df2, right? Player will from my df1 is mapped to df2, but this is a costlier operation, right? So it has to do that internal calculation where it will see all the column names from both the data frames and try to do the union, right? So rather from performance improvement perspective, use union and take the columns from one of the data frame, put it in a select command and do it. So that should improve the performance. Okay. So this will make sure that both sides, the column orders are in the same order. Okay. Yeah. So I've shown you how to create a data frame from RDD, right? So there's a function called as create data frame, right? So either you read from a file or from JDBC, from Parquet file, CSV file, XML file, or you can read from a data frame. Or from a RDD, right? So what we had seen in previous sessions, Spark core, right? So I can take that RDD and convert it into a data frame using create data frame. Okay. What else? Performance tuning will come there. So one thing is from the performance perspective, right? So for example, if you see here, there's multiple places where I'm using df2, right? So I'm using df2 for calculating join df. I'm using df2 to calculate df3, right? And if in somewhere, if I've done df3.show, if you remember in Spark core, as soon as an action operation is created, there's a separate job gets created. So this is a separate job and this is a separate job, right? And in separate jobs, once this particular job gets over, df1 is garbage collected, df2 is garbage collected, df3 is garbage collected, right? So again, in the next job, if I'm using df2, that means it has to go back and recalculate what is df2. Okay, df1 dot with column. What is df1? Df1 is df cricket dot select. So that will create performance issues, right? So rather than doing that, if you know that a certain data frame is going to be used across your program, you can do persist. Okay, df2 dot persist. So this will make sure that each partition in each executor temporarily stores the data of df2 as long as this particular Spark application is running. Right? So, right, so let's say df2 partition 1 was here, partition 2 was here, right? So at this point, also I put this in a wrong place. This should have been before the action operation. It should have been here. Okay. So as soon as this job got completed, df2 still exists because it will be temporarily saved in the RAM. Okay. Temporarily will be saved in the RAM of that particular executor. All others, df3 will be garbage collected, df1 will be garbage collected. Okay. So next time when I do df2, when I refer df2.join, it will go back to the RAM and say, okay, it is already persisted. From there on, I can pick it up and do whatever I want. Right. So that is why from the performance aspect, if we have any data frame that we are going to use regularly, make sure that you do persist. But at the same time, do not persist all the data frames. What will happen? Your RAM will run out of memory. Then you do not have any space for running any of the other transformations. Okay. So that is why persist should not be used. Okay. Transformation is select. Okay. So let me go back and remove all this. Okay, so select command is basically selecting all the columns that is equivalent to your select column 1, column 2 from table name. That is the equivalent SQL, right? But in a DataFrame API, we have df say df1 equal to df cricket. Oh, I have not loaded the file. Basically, I have not loaded anything. Yeah, now let's select. Okay. So first we read the cricketers file, we gave the schema and put it in a data frame called as cricket. I told you that print schema is a function. It's neither transformation or action. It will show you the schema of the data frame, right? So what is the column? What is the data type, whether it's nullable or not. Right? The third is an action operation called as show. Show is equivalent to collect in RDD. RDD had collect, data frame has show, right? So it will display the data frame. So if you see here, it is displaying the data frame, right? So now the next transformation function is select. Okay, so we take the data frame name, okay, and do select. Within select, we can give column names, right? So let's just say I just want to see ID and player name. Is it player name? Yeah, player name. And then now my df1 has only ID and player name. So this data frame has only two columns, ID and player name, right? Let me switch this off. Okay. So we can either write select command like select a function like this, or we can do it in a couple of different ways. We can do df cricket. We can use the data frame name dot ID column name and df name dot column name. Okay, so this is another way. Third way is to import column function from Pyspark .sql functions import column. Okay, and once you import it, you can do column ID. Okay. So basically, this all the three notations may work for any of the functions, but you have to check. Okay, I'm not saying that all the transformation functions you can use all the three notations. That is either using column function or using the data frame name dot operator or just the column name. Okay, so you have to check which one works, which doesn't work. But for select, all the three approaches work. Okay. Oh, sorry, my bad, my bad. Thanks. So any of these approaches will work with select. Okay. So, but for other transformation, you need to check which whether using column will work or just the data frame name dot operator, that approach will work, or just the column name will work. Okay. So next transformation is filter function. But first, let me do one thing. I'm just going to select all. Okay. And in my DF2, I'm going to say filter everyone who's from India, right? So DF. I have not calculated the year, correct? Okay. So before filter, we'll go with mutate. Okay. So the next transformation function is mutate, right? So mutate is basically with column. Okay. So that's the with column function. Why it is calling mutate is it changes the data frame, in the sense it adds something to the data frame, right? So we add a new column using the with column function. Okay. With column. And we will call it as country. Okay, and how do I define country is Sebastian def1 dot player name, comma 2, 3, 4, 5, 6. Let's see if this works or not. Sebastian is not defined. What I can do is string. One, two, three, ANDIA 5. Substring is not defined. Yeah, okay. So now I do get India, but others are not that correct, right? What else? What other logic can I do? What we'll do is we'll create a UDF. That's a better approach. Yeah, so here I'll tell you what is a UDF, user defined function, right? So if you see any function that is by default given by Pyspark or Python may not work, right? The logic may be complex. So what we can do is we can create our own function, and with the with column mutate transformation, we will pass that particular column and get the result from the UDF. Okay, so what with column does is, so here I'm creating a new column called as country, and then the logic for the value of country. Sometimes it can be very simple. For example, let's say they may tell you that, okay, create a country for now with null values or zero values. Later on, we will take care of it. So what we can do is we can do lit. So lit is a function that will copy the same value for all the rows for this particular column. So it will copy value 0 for all the rows for the column country. Okay, so we can do that, but that's a very simple logic. Or they may say that, okay, country may be df1 dot runs into df1 dot strike rate. Okay, some not countries, let's say runs into strike rate is what let's say MVP points. Okay, but this is a very simple logic, right? SR df1 doesn't have SR. Show SR. Okay. Okay. Yeah, df2. Yeah. So let's say I calculated this particular MVP. Okay, so they say, okay, boss, we need to create a new column called as MVP, and this is a logic, right? So these logic is very simple to do, but for countries, you saw that the logic was very difficult. So let us create that column using UDF. Okay, so let me create segment here. Here def country calculations, take player name, okay. Then on that player name, so I get a player name. Okay, on that player name, let me do list of what can I say? Split list. Okay, let's connect that. Then player name, which is a string, split based on this. Okay, I'll take directly as a country only. So player name, basically player name column is always a string, correct? We have seen that it's a string. Okay, so I'm going to split on this. So this will be list element 0. This will be list element 1. Okay, so I will take list element 1. But what if it doesn't have this, right? Okay, whatever. Let's see if I get any error. And after this, I will split on this again. So I got this much, and I'm going to split on this part on this. So this will become 0. Okay, 0. This should be good enough. Hoping that it is. Let us see if we get an error. Return. I'm pretty sure I will get an error, because there may be columns where it doesn't have any of this, right? Okay. So first thing is we define a normal Python function. Okay. Now we need to tell Pyspark that you convert this particular normal Python function into a user defined function. Okay. So we need to register it. So first thing we'll call it as country cal UDF equal to UDF, and I'm going to call country call name of the function and the return type, which is string type. String type I've already imported using types, so I don't have to import it again. So what we are saying is, boss, you take this Python normal Python function, convert it into a UDF, and the return type is string type, and we are going to call this UDF as country cal UDF. Right? So all I need to do is now pass this function for the player name, right? df1 dot player name. So player name will be passed to this UDF function, right? And this UDF function will calculate country and return country value, which will go to the column country value for each row, right? So this way, hoping that we solve the previous problem. Yeah, luckily no error. And hopefully, yes. Okay. So now we have a country column. Okay. So next, then we can use the filter function. So df3 equal to df2 dot where country. Let's say my boss comes and says we want to only show stats for Indian players, right? So okay, and now I do df3. So now I'll get all the Indian player names, right? Virat Kohli, Irfan Pathan, Ashwin, all of this. Okay. So here we use two transformation. One is mutate with, that is with column. Next is with the where clause. Okay. So there is the, here you may see that we are not using, sorry. We should have used filter, right? So there is no difference between where and filter. Filter was the older way of doing it. Okay, I could have done the same thing with filter as well. df2.filter, and I can just copy paste whatever here, and it will still work. There is absolutely no difference. The only reason why they brought, I told you, in Spark DataFrame APIs, they try to match what we do in SQL, right? So in SQL we have where clause, but in here we had filter earlier, right? So that's why they decided, okay, why not change the name to where? But because people have already developed using filter, we need to maintain backward compatibility. That is the only reason why filter exists. Okay. Otherwise, both are same. If you hover over it, in fact, you will see the example saying that where is an alias for filter. Okay. And you see the definition also, it is showing filter only. So there is no performance improvement, nothing. Only thing is it makes it more sensible. People reading it for the first time, people who are coming from an SQL background, for them, it will become easier to understand the code. Okay. So that was about filter transformation. And we saw with column, which is our mutate transformation. And we also saw how to create a UDF, right? So this is very important because there'll be a lot of times where you're expected to create a column, a new column for the data frame, and the logic is very complex, right? So that point in time, we'll definitely be working with UDF. Let's say I only want certain columns, then I can use ID player name runs country. So I only need these many. Okay. So this is equivalent to select ID player name runs country. Let's say the table name was df2. Okay. I'm just giving an example where country equal to India. Okay. So this is your MySQL equivalent query. The next transformation, that is mutate summarize. Okay. Summarize is nothing but your group by clause, right? So let's say my boss comes and says, show me number of players per country, right? I want to display that data. So what we will do is, let me remove this. df2 has country calculation done, right? So df count by country equal to df2 dot group by column name, which is country. Okay. So at this point, this particular, when I use group by, the output is basically something called as a group data frame. Okay, I'm calling it GDF. Okay, so on this GDF, it is not a normal GDF, so I cannot use action operation and transformation operations what I've used, right? For example, I cannot do GDF.show. It will say that group data frame does not have attribute show. Okay, so now if you see, yeah, group data object has no attribute show, right? So we need to convert it back to your normal data frame, right? You would have seen this in SQL also. Can you do this in SQL? Let's select star from df2 group by country. You run this, it will give you an error saying that some of the columns are not part of your group by clause, right? Only the group by clause can be whatever column has been mentioned in group by clause, that only will be eligible for display, right? Same thing here. So now at this point, you're trying to say select star from df2 group by on country, right? So it's saying you cannot display that, right? So you have to apply some sort of an aggregation on top of that. And I'm going to say and let's say on runs I want to do total. Okay, so the ask is get the total number of players per country and total number of runs scored by a country, right? So if India, I have to sum up all the for all the players, I need to sum up the runs. So the equivalent query is count star and sum of runs and then the country name. Okay, so this is what is the ask, right? So get me all the countries, right? And against that countries, I need to know total number of player, total, and against that country, I need to know what is the total runs scored by the particular team, right? So that is the ask. So what I've done is on the group by, in order for this to be able to convert into a normal data frame, df country, okay, I have to use the ag function. Okay, so in this ag function, we have to pass a dictionary. Okay, so this particular ag function will only work with group data. Okay, so unless you do not have group by, this aggregation will not work. Same like when MySQL, if I just remove this group by condition, you'll get an error saying that data is not grouped, right? Same thing. So this is a special function that only works with group data, right? So once you have used group by, use ag, within that you give a dictionary, and you can give for multiple columns what are all aggregations that you want to perform, right? So I want to perform on the star, I want to perform count, then I have to give star and then count. For the column runs, I'm going to do sum, so I have to give sum. Max runs if you want to see, or max hundreds, let's say. Column name is 100 if I'm not wrong. Column name is 100. Let me just see. df2.show. Yeah. So on column 100, let's say I want to do max. So okay. So now if you see, country is this, max number of hundreds is this, total number of players is this, total run scored is this. Okay. So we have achieved whatever was our objective, right? But we'll come back to this again, because after group by we need to do order. Okay. So anyway, it's not ordered as at this point. Okay, so we have achieved the whatever goal our goal was, right? Whatever our boss command, whatever problem statement he has given, we have done it, right? Sum of runs greater than, let's keep some minimum here, so that we get genuine teams. Okay, so for now we'll remove this.
Let's have a quick quiz question, guys, and the question is, Dash is a distributed graph processing framework on the top of Spark, and your options are mlib, GraphX, Spark Streaming, or none of the above. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.
Okay, so if this is clear, we'll go to the next one, which is order, arrange. Yeah, sort or order. So again, same thing, sort and order. Earlier, the older function name was sort. Newer function name is order by. That's it. Okay. So even when you do order by and you hover over it, it will give you examples of all sort by only. So if you see, the example they're giving is sort, because it's an alias. Even the definition is saying sort. Just like where class and filter, where function and filter function, same thing. There is absolutely no difference between order by and sort. Okay, but we'll go with the order by because it is more equivalent to your string columns. Okay, I mean more equivalent to your SQL, right? So this is equivalent to order by. We will say max hundreds. I want to. Oh, here I am not done. Whatever it is, max 100 in descending. Okay. So for that, we will give a column name, max 100, and order by. Okay, we'll use the other notation because it is easier to give descending or ascending, but there's a way to do that without having to do it. Yeah, DSC. Yeah. So function, where's function? Okay, DSC and sorry, I don't know why I did this. Okay, so now, oh, India is only 400s. That's the highest. Okay, fine. So I did order by. Within that, I've given called the descending order function, and then I've passed the column name. There's another way to do the same thing. We'll keep this aside. Right. Stop this. We'll call the df notation. If you remember, we can use the df name dot max 100. The reason is max 100 is kind of a function, right? And 100 is the number. That's why I didn't want to take. I think this will work. So sometimes you may have column names that are like this, right? Which may be like Python function name, and it may be an integer and all those stuff, right? So in that case, instead of dot operator, use the what do you say, brackets, square brackets, okay? And then do descending. Okay, so this will also work. If the column name was simpler one, like if I want to do it based on country, I can use the dot operator again and then do country, descending, and then it is setting it based on the country. Okay, hope this is clear, right? Just replace order by with sort and you'll have the old approach. Okay, just do sort, it will be old approach. No difference with any performance, any syntax, anything. Everything, whatever works in order by works in sort, whatever works in sort works with order by. It is like an alias, right? Okay, so next comes join. Okay, so if let's say you have two data frame and you want to do a join on that, you can do that. What is the use case for join here? Let me think. Let me replace this. Okay. What we can do is, I'm thinking of a scenario where we need to join, right? Okay, what I can do is I'll create a country-wise data set. Okay, country data, and I'm going to join with the original df2 based on country, and yeah, I'll just show the total number of players, even though it is for example, the ask is I'm going to show Virat Kohli and he plays for India. He has scored this many runs. I want to show how many players are there in his team, right? So for that, I will have to join the country data with the original df2, right? So I will take join df equal to df2 dot join with country data. So this is kind of like a inner join with some self, right? Because the entire thing is one table only. Everything has been derived from the same table only. But at this point, you just consider that there are two different tables. Okay, it becomes easier. Country data, how do you want to join? And I'm going to say, based on what you want to join, right? So df2 dot country, or either I can give it like this, equal to country data dot country. So this is your on condition, right? So join these two tables, these two data frames on country column from df2 and country column from country data, right? Or you can do, since both the column names are same on both the sides, you can just remove this and just replace it with country. Okay. And let's say if you have multiple multiple conditions, right? So country equal to country name, let's say 100 equal to df2.100 equal to this won't work. 100 equal to country data 100, right? Equal to. So I can have multiple. So I have to put this inside the list, the conditions. So if you see, it's a list. Within that, I have to give comma separated conditions. So this is one on condition, this one joining condition, this one joining condition. Okay. And that is when you need to use this kind of notation when the column names are different, right? But in this case, column names are same, right? So I can give country comma 100. I mean 100 is not common because this column name is called as max 100, whereas df2 has 100. So this will not work, but I'm just giving an example. If there were both sides the column names were same, you can just put it like this, right? So now let me not just do that. Okay, so join on country, and how do we want to join, right? So we know the different kinds of join: right join, left join, inner join, right? So how do you want to do it? I am going to do it inner join, and then on this join df, I'm going to show inner is not defined. Sorry, I need to give string. Okay, so now if you see for Virat Kohli, okay, I took the country data and joined it with it. Okay, so these three columns came from there. So the next function is union. So here there's a bit difference. Okay. So let's say why I want to do union here. I'm just going to take some random data. Okay. So df1 and df2. Yeah, I'll show you the difference. Yeah. Let's say you have two data frames and you want to do union between them. That means you want to horizontally join both of them, right? So then you can use the union function and you can give the other data frame. Okay, then you can do show. Okay, so if you do this, first thing is you need to remember that both sides, the number of columns, both the data frames, the number of columns should be same, or else you'll get an error saying that right hand side has this many columns, left hand side has this many columns. Now you see, yeah. So the error is union can only be performed on tables with the same number of columns, but the first table has 17 columns and the second table has 19 columns, right? So that is the reason why when we use, I mean, this is same with even SQL also. If you do not have the same number of columns within the table, you get an error. But how can we now fix this? Okay, so there is one function called as columns for a particular DF. For example, when I do df1.columns, it creates a list. Okay, it returns a list. Okay, when I do this, so you can use that list and we can put it in select. Yeah, so this is one more. This is a third approach. Okay, so let's say you have a list of columns and you want to say, use it in select command. You just put it in a list and use it in select command. Okay, so that way only those columns will be selected. So now what I did is I took the df1 columns, the data frame 1 columns, selected all the columns from data frame 1. Okay, and from data frame 2, I only selected all the columns that are there in df1, right? I know that df2 has similar columns. Apart from that, it has MVP, points, and country, which is extra. So it will drop those because I'm only selecting the columns that is there in df1. Hope you understood this, right? So this is one way of fixing it, making sure that there's a column list that is same, right? So now if you see, it worked. Okay, but it should have given me double, right? Virat Kohli is there in both DF1 and DF2, but you don't see it here. The reason is union will only keep one single copy. If everything, all the column values for a particular row is same between DF1 row and the DF2 row, it will only keep one of the copy. Okay. So earlier they had union all. This would give you the duplicates. Let me do where e equal to 0. What? Okay. Their name. Yeah. So if you see, both of them got copied, right? But if I do union, it will only keep one single copy. Oh, they changed it. That is why they depreciated it. Okay, sorry, my bad. So union does the same, does carry the copy itself. I think earlier they were separate. Okay, that is why union all is depreciated. If you run it in your cluster, you'll get that union all is depreciated. Okay, now I know why. Union already has it. So how do we then now drop the duplicates? So there is another function called as drop duplicates. This will drop any row that is completely same. That means all the columns are same, column values are same. So it will drop all those duplicates and you'll get only one single copy. Okay. So that is union. Okay. So one other thing is, let's say there may be a DF2, right? DF2 may not have player name in the third place. Okay, so first of all, yeah. So DF2 may not have second column as player name. Player name may be the first column, ID may be a second column, whereas DF1 has ID as the first column, player name as the second column. So in that case, if I do union, it will still do union, but it won't match the columns. ID of DF1 will be union with player name of DF2, right? So that will create a lot of problems. So they came up with a new function called as union by name, right? So union by name will make sure that all the columns are ID column in DF1 is union with ID column DF2, right? Player will from my DF1 is mapped to DF2, but this is a costlier operation, right? So it has to do that internal calculation where it will see all the column names from both the data frames and try to do the union, right? So rather from performance improvement perspective, use union and take the columns from one of the data frame, put it in a select command and do it. So that should improve the performance. Okay. So this will make sure that both sides, the column orders are in the same order. Okay. What else? Performance tuning will come there. So one thing is from the performance perspective, right? So for example, if you see here, there's multiple places where I'm using DF2, right? So I'm using DF2 for calculating join DF. I'm using DF2 to calculate DF3, right? And if in somewhere, if I've done DF3.show, if you remember in Spark code, as soon as an action operation is created, there's a separate job gets created. So this is a separate job and this is a separate job, right? And in separate jobs, once this particular job gets over, DF1 is garbage collected, DF2 is garbage collected, DF3 is garbage collected, right? So again, in the next job, if I'm using DF2, That means it has to go back and recalculate what is df2. Okay, df1 dot with column. What is df1? df1 is df cricket dot select. So that will create performance issues, right? So rather than doing that, if you know that a certain data frame is going to be used across your program, you can do persist. Okay, df2 dot persist. So this will make sure that each partition in each executor temporarily stores the data of df2 as long as this particular Spark application is running. Right? So let's say this is my driver. Right, so let's say df2 partition 1 was here, partition 2 was here, right? So at this point, also I put this in a wrong place. This should have been before the action operation. It should have been here. Okay, so as soon as this job got completed, df2 still exists because it will be temporarily saved in the RAM. Okay, temporarily will be saved in the RAM of that particular executor. All others, df3 will be garbage collected, df1 will be garbage collected. Okay, so next time when I do df2, when I refer df2.join, it will go back to the RAM and say, okay, it is already persisted. From there on, I can pick it up and do whatever I want. Right. So that is why from the performance aspect, if we have any data frame that we are going to use regularly, make sure that you do persist. But at the same time, do not persist all the data frames. What will happen? Your RAM will run out of memory. Then you do not have any space for running any of the other transformations. Okay. So that is why persist should not be used. And I had already shown you last time how read and write function works, right? So anyway, I'm going to do that again, right? So we have a reader function, we have a writer function, right? So in reader function, we basically do something like this. I think I deleted them. It's fine. Spark write, sorry, read JSON. So to read the JSON file. For Parquet also, we have a special function, just like CSV and JSON. And for all other types, we have to use format. Spark read format. We can give ORC, load, and then option, header true. Yeah. So something like this, right? If it is not either CSV, JSON, or Parquet, then we have to use format, right? Because they created a separate function for these three because they are highly used data. I mean, for source files, right? So Avro, ORC, Hive, everything you can use format, right? And if you want to read from a database, we do JDBC. And then we give URL, password, and everything. Okay. So this is the way we used to read, right? Similarly, while writing, only difference is we don't call the Spark session object and then call the write function. We directly take the data frame and we use the write function. Okay. And just like for read, we have CSV, JSON, and Parquet separate function for them. In write also, we have separate function for CSV, JSON, and Parquet. Right. So, and last time, like in RDD, I had shown you that we do not get to decide the file name. We can only give the file path, right? So we'll do content output. This I'll show here. Anyway, we have read everything. I don't want union and everything. what I would want is to be able to write. Yeah, we'll write df by country. Okay. Df by country, right? CSV. And if you see here, there's a mode option as well. Separator compression header is true. So here header is true. And we also have another thing called as mode, and I can do override. So this was something not available in RDDs, right? So if you are writing to in an RDD, every time we were writing to the file, that file shouldn't, I mean, that folder shouldn't exist, right? Or else you would get an error saying that the folder already exists, right? So there was no way for us to overwrite it. But data frames, however, have a function in which we can mention the mode. So it can be either override or append, or if you leave it as is, then you'll get an error. Okay. So default is write only. Okay. So in that case, you have to make sure that this file folder doesn't exist. Output folder doesn't exist, right? However, if we give overwrite, it is fine. We can, that particular thing can exist. Now let us see content output. Okay, so if you see so it was divided into these many executors. These many executors separately wrote it to the storage, right? And I don't want this, right? My client may say, no, boss, I only want one single file, right? So just like in RDD, we had seen repartition, here also repartition works, okay? So we can do repartition, and we'll do repartition 1, and we'll write it. Okay, so now we have only one file. We can also do cat instead of this. Okay, so we have written CSV file where there's country, there's the max column, then there's the count column, then sum of runs. Okay. Okay, having said that, let's go back. So these are just like write, I mean, just like read. Write also has separate function for CSV and JSON and Parquet, right? Very commonly used, right? So we can have same thing. Can do JSON and same thing. Can do Parquet. And for all others, we need to use format. Okay, right? Format. Let's say we are doing XML, and then save. Okay, so in read it would be load, here it would be save. Okay, option row tag. Okay, something like that. You have to see what are all the options are there for XML. Okay, so that is another headache. You have to go and check what are all the options available and what are all options you need to define for the data frame to be able to write it into XML, right? For Avro, everything you have to use this method only. For any format outside of CSV, JSON, Parquet, you have to use this. For JDBC, we have a separate function. So we do mode JDBC, then I think URL, blah, blah, blah. and then save as table, and then the table name. So slightly bit different, but overall it looks the same. Okay. Yeah, before that, one more stuff. Okay, so then it's not part of your syllabus, but I'm anyway giving it to you because that's also important one. Okay. Okay, so in Hive we have a couple of analytical functions. Okay, and you will encounter them most of the time, right? For example, we may need to we may have a same primary key from the source, right? But in target we cannot enter multiple rows for the same primary key, right? So in that case, what will you do? We'll do something called as windowing. Okay, so and windowing, what happens is, just a minute. I'll explain here. So let's say I have Spark data frame, okay, which is whichever at the data from source. For ID column, which is my primary key, I have two rows for same ID. Okay. So my job is to make sure that I only pick either one of them, either this row or this row for ID1, right? So what I will do is I will create a separate window where all the same ID with all the rows with the same ID will go into that window. So for ID1, which has two rows, it will go into one window. Okay. ID2, which has only one row, still it will go to a different window. And then ID3, which also has two rows, will go into a separate window. Okay, so now I have three different windows, right? On this window, I'm going to apply order by, okay, and I'm going to say that I'm going to apply another function called as row number. Okay, apply row number. First, you sort it by some order by some, let's say, date column. So there's a date column, right? So the latest date will be on top and the next date will be on bottom, right? Now, once it is sorted, apply row number function. That means give a row number to it, right? So the one at the top will get row number 1. The one at the bottom will get row number 2. Okay. Here there's only one record, so row number by default will be 1. Okay. And then here also I'll sort it out by date, and then I'll give row number 1, row number 2 here, right? So now what happens? I can say that for this data frame 1, df1, row number, only pick those rows where row number is 1, right? So this will get picked, this will get picked, this will get picked, right? So this won't get picked, this won't get picked. So that way I can remove duplicates, right? And this is just one of the function, one of the scenarios where you would need row number, right? So for that you need to create a window. How do we create it? So for example, we'll take here only. We do not need to drop duplicates. Rather than doing this, I will say just give me a minute. Huh? Okay, where was I? From Pyspark .sql .window import window, and from Pyspark SQL functions import what we need row number. Okay, so now let me go back. First, let me create window create equal to, or I will give some name that makes sense. Window spec I will give. Okay, window spec equal to window dot partition by here I will say partition by sorted by. So if Virat Kohli same record, right? There's no difference, but still okay, fine. I'll just say runs. Okay, partition by runs, and then order by partition by player name. Sorry, my bad. So now Virat Kohli will be in the same windows. Both the Virat Kohli will be in the same windows. Okay, and I'm going to say order by runs. So within that window, we'll sort it out on runs, and it will do the ranking. I mean, it will give ranking on top of it, right? That is what I'm hoping. Let us see. Okay, so now Windows spec is defined. df1 dot with column df1 equal to just df1. Okay, df1 dot with column. So I need to create a new column, and I will say row number only. Okay, again, this is something that I'm giving. We can give anything. So now I'm going to use the row num function to get entries for this column. Within the row num function, I'm going to pass the window spec. Okay, and let me do df1 dot show. A window spec object has no attribute order by. Why order by is not there? ORDER. Oh, sorry, my bad. Case sensitive. Okay, now what is the issue? Row number is not defined. Row number, sorry. The function name is row number, my bad. Row number. Again, which one takes 0 positional argument? But sorry, my bad. Okay, row number dot over. Yeah. It's saying that apply this function over this window. Okay. So now if you go and see, okay, row number field got created. Let me just make it much easier. Okay, we'll just select Virat Kohli. So you will see that there are duplicates. The first one had 1, the second one had 2. Okay. There's only one Virat Kohli. Did we not do a union on it? Ah, here. Sorry, my bad. So I'll do one thing. df5 equal to this, and on top of df5 we will do with column and with column this. Yeah, so if you see the row number for one of the rows is 1, the other row is 2, right? Even though everything is same, what happened is these two went into one single window, right? Because I created a window based on player name, right? So Virat Kohli went into one window, Rohit Sharma went into one window, Jadeja went into one window, Ashwin, all players went into separate windows, right? And in that window, I sorted the data by runs, even though it is same, it did some sorting, okay? And whichever was first row was given the rank, I mean, row number as 1, second row was given the row number as 2, right? So now if I want to remove duplicates, all I need to do is and what is the column number, row number equal to 1. So this way row number 2 goes away, right? And I get to remove the duplicates. Okay. So afterwards I can call another function called as drop column or just drop. Okay. So drop will drop a column. So I will drop row number. And the row number also gets dropped. I get the original columns that was there in the data frame. And at the same time, I got to drop the row number column, right? And also the duplicates. So here drop duplicates works because everything is same, right? Because when we do Virat Kohli, we saw both the rows had all the columns same. But what if there was a requirement where, it's not everything is duplicate, okay? Only the primary key, which is player name, is duplicate. Everything else is having different values and we need to pick the latest one, right? So in that case, you will end up using the window function, right? And that may not be the only requirement. Okay, I'm just giving you a scenario. Analytical function can be used for n number of things, right? So we have a couple of analytical function, right? Row number is one of them, and next is important ones. I'll tell you. Lead and lag. Okay, so what will lead and lag do, right? So in my window, let's say lead. They have some examples. Yeah. So let's say I have a department ID, right? And for each department, I have some INS amount. Okay. Department ID. I want to find out for this particular participant ID, what is the next lead amount in my department, right? So there are like 3 participants, okay, 6, 2, and 5 for department ID 111. Okay, and each of them have some initial amount or installment amount. Yeah, I think installment amount. So installment amount is there, right? I want to find out, okay, this guy's installment amount is 9,000, but against this guy, I want to see the next person's uh, you know uh, installment amount, right? So participant 7. So there is no participant 7, right? So in that case, lag will be 0, right? But for example, for participant 5, I need to show the installment amount of participant 6. So then it will show me this, right? For participant 2, I think, is there a participant 1? Yeah, there's a participant 1. Yeah. So participant 2 needs to show me the installment amount of participant 1, right? Which is this should have been 10,000. Order by department ID only. Okay. Okay, so here the order is they've given as department ID, not participant ID. My bad. Okay. So just did a random sort on the department ID, and in that 9 is before 2, right? So it is giving 9,000 here. 5, I mean 2 is before 5, so I'm getting 2's installment amount, right? 5 is before 1, so I'm getting 1's installment amount. right? So that is what lag does. So you create a window. Within that window, whatever rows are there, you can use the value of the previous row for some particular column, right? And create a new column over it. Okay. Lead, on the other hand, is reverse. It is ulta. So here I'm getting the installment amount of the next row, which is 2, right? For 2, I'm getting the installment amount of 5. For 5, I'm getting the installment amount of 1, right? So on and so forth. Right? So for each department, separate department ID, it will do the same thing. So this is one window. So it created one window here. It created one window here and one window here. Sorry, not here. One window here and one window here. Okay. So if you see for the third window, there's only one record. So lead and lag will be 0 because there is no previous record or there is no next record, right? So this is what lead and lag is. This is also quite important. Next is, just let me know if you didn't understand it. These are all not Spark related functions. Actually, now it is there even in MySQL. Okay. So this is kind of from MySQL itself, you can say. So if you're using MySQL also, someday you would end up using it. Okay. Now, if there's no question, then the next one would be rank. Okay. So we have seen row number, rank, and dense rank. So what is the difference between these three, right? So row number will be always unique. Okay. So if there are 2 rows in the window function, one will be 1, the second will be 2, right? 3 rows means 1, 2, 3, right? But rank, if the values given in the order by, that's why order by didn't matter here, right? Where is that? Virat Kohli had everything same, even the runs based on which we did an order by, right? It was same, right? But it still gave different unique row numbers, that was 1 and 2, right? But in rank, that won't happen. If the runs are also same, right, then it will give 1 and 1, right? And the next one will be 3. If let's say I had 3 records for Virat Kohli, in one record the runs was 293, the another record also 293, the third record has 393, right? So the first 2 records will be 1, rank will be 1, the next will be 3, right? So it will skip 2 because it is already given for 2 rows, it has already given 1, right? So it will skip that next number, right? However, dense rank will not skip the next number, so it will be 1, 1 and 2, same scenario I'm telling you, right? So let me show you for row number. Yeah, I will show here only, you can see it better. Oh, there is no third one, right? That's a problem. Everything will be 1 here. Yeah, okay. I don't have the data here. So let's say I had one row where runs was 293, 293, 393. Okay. So row number will give you 1, 2, and 3, right? Rank will be 1, 1, 2.
3.
Dense rank will be 1, sorry, 113, my bad, 113, and this will be 112. Okay, that's the only difference. So dense rank will not skip the ranking. However, rank will give skip 1 because here it is already given 1, right? So for 2 things it has given 1, right? If again there was another one, this would have been 4, so it would be 114. Okay. However, this will be 2 only. Dense rank will be 2 only. Okay. So that is the difference. So this is 1, this is 2, this is 3, this is 4. Okay. This is 1, 1, 4. Okay. This is 1, 1, 2. Okay. So that is the only difference. So directly we can read from a Hive table. Let me start my cluster. I cannot show Hive here, unfortunately. I have to show from the cluster. Let me start putting 168.1.1.15. On the search. So system CTL start IP tables. Stop IP tables. Let's say one system CTL start IP tables. Stop IP tables. Set slave 2. CTL start IP tables. Stop IP tables. Set. Yeah, start all search. Name not secondary name. Okay, search slave 1 JPS. Okay, it's working. Clear. Exit. Now Spark home. It's been. I'm gonna search. Okay. Okay, everything is working here. Right? Yeah, one more thing. So we have downloaded. So if you look at the files, right? That's when we created the cluster, if you remember, we have downloaded Hive tar.gzip, and we have also extracted into /etc/hive, right? And this is available in all three clusters, this folder, in all three slave machines in our folder, right? So, but we cannot install Hive on all the three machines. That is not possible. So how does Hive work is, it gets installed in one machine, right? And it can be accessed from all the other slave machines. Okay, slave machines or master, whatever it is, right? So that is how Hive works. So out of the slave 1, slave 2, and master, we need to pick one of the machine where we are going to use or install Hive. Okay. So in order to install Hive, no, Hadoop version and all is fine. These are all done. Yeah. First thing is we need to copy this hivesite.xml. So if you go and download from the this one, what do you say, Google Drive, I've given a Hive setup folder, right? So Hive setup folder has hivesite.xml. You copy this and paste it inside I think lib. Let me do cd lib. Yes. No, this is all jar files, not this one. Yes. Conf. So there's a conf folder inside the Hive folder. So it is cd/etc/hive /conf. Okay. So within this conf folder, you need to copy hivesite.xml. I've already copied it. So copy this hivesite.xml, paste it inside the conf folder. That's all you need to do, right? And after that, so 3 steps, Notepad++. Step 1 is pick one of the slaves. Spark Hive. Check if files exist in /etc/hive. Copy hive site.xml available in hive setup from Google Drive, and paste it in /etc/hive/conf. Yeah, next step, we need to set up the schema. So we need to do is fine. Yeah, have Hadoop running in the backend. Start Hadoop master and master. Fifth step is this, setup environment. Downloading is done. Fine. Don't be. Yes, schema tools. We need to initiate the schema. Okay, so this will be in /etc/hive/bin, and then there's a schema tool script. We need to call that, and we need to mention DB type is Derby, and then I need schema. You shouldn't get any errors. Okay, output should not have any errors. And then sixth will be, so this any other thing I don't remember. It is completed, I think. Yeah, fine. So that's it. Check by calling interactive shell. So for that command is, that's a type hive, it should be there. Okay, we will do this. Let me open the new cluster because I'll show that installation also. Why? Exit. Okay, stop all $search. So I'll go with the new one that we have created. Right, so this is the cluster I created with you guys. I'm opening that.
Let's have a quick quiz question, guys. And the question is, Pyspark UDF is dash, and your options are user-defined functions, user-defined forms, user-derived functions, or none of the above. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.
It's 199. Okay. 92.168.0.199. Okay. CP. I'll install it on slave 2. Okay, so let me go to slave 2. 154. Okay, 192.154. 168.54. Okay, so now let me do all the steps. Okay, first thing is go to Hadoop setup, sorry, Hive setup, and here /etc/hive go to conf. So Hive side XML already I've copied in when we are installing, but anyway we can copy it again. Okay, and then go to SSH slave 1 cd/etc/hive/conf DOS to Unix hive site.xml. Okay, so now come back to which one system ctls dot ip tables so slave 1 system ctls dot ip tables exit. So slave 2 system ctls dot ip tables exit. Now let me start Hadoop, start all.sh. Before that, let me go back to the notes once. Done. This also done. This also done. Yeah, starting Hadoop cluster. Okay, so now let me just do JPS. Name node, resource manager, second good. Okay, SSH slave 2. JPS, just confirming. Okay, fine. Node manager, everything works. Okay, now I need to call the schema tools. I need schema till I need schema to copy and then enter slave 2. Yeah, I'm in slave 2. Correct. Okay, fine. Just make sure that whichever slave you're going to pick, in that slave only you need to run this command. Right. Okay, so there was no error here, so that means it has been installed correctly. Now just do Hive and check if it is working or not. I will give you a Hive interactive shell. Okay, this command should give you Hive interactive shell. Yeah, so So everything in Hive query language, HQL is whatever you have done in MySQL. Same thing. Show databases, right? I'll show you the database. Create database. Create database in Intellipaat. Okay, now show databases again. Intellipaat exists. Okay. Use Intellipaat. Create table test1. Name is string. ID integer. Semicolon. Insert into test1. Values. So, one. So I told you Hive is an interface. In the backend, it is running on MapReduce, right? So if you see here, it says how many number of mappers used, how many reducers used. Task takes zeros, reducers, number of reducer tasks is 0 because there is no reducer operation in this particular in SQL. Okay, but however, mapping, it has taken how many mappers? Number of mappers is 1. Okay, it has taken 1 mapper. Okay. However, if you see there's a warning. Hive on MapReduce is depreciated because Hive 2.0 has a can use a different execution engine, that is Spark or Tez, right? So for Tez, we need to set it up in hivesite.xml. For Spark, you need to call from Spark itself, right? Pyspark shell or Pyspark code. You can call Hive and it will use Spark engine only to execute it, right? So that is one thing. So now let's do select star from Intellipaat.test. Okay, so you can see the entry. Okay, so this is your Hive, right? Now let's exit. So one difference between Hive and your normal SQL is, I can go to 192.168.0.199. Hive is used for your data warehousing. Now in today's time, it's a fully fledged data warehouse. Okay. So in this is a distributed data warehouse. The reason is in the backend, all this whatever data is being stored, right, is stored in HDFS, and HDFS is what? It's a distributed file system. So your entire database is now a distributed database. So it actually started as just like an SQL-like interface, okay? But in today's time, it is a fully fledged data warehouse. You can people are using it for data warehousing requirements, but like certain concepts are not available what you see in normal data warehouse, like you have constraints, primary key, foreign key constraint. There is no such concept. There is no primary key, there is no foreign key, both in Spark and Hive, right? However, you can make sure that you may say, okay, fine, if primary key is not there, then how do we remove duplicates? I just showed you how we do it, right? We can use rank and row number or whatever it is, or you can do drop duplicates and make sure that duplicates don't go into your Hive table, right? So that is done on the ETL side, making sure that data doesn't get duplicated. But there is no concept of primary key and foreign key or whatever constraints you have seen in MySQL. So that is one difference, right? And it's also a fully fledged data warehouse. MySQL is a database at this point, right? So now what I was talking about is this, right? So the data is again the underlying table data, right? So test1, whatever data exists is in HDFS. So if I had written, if the data size was more than 128 MB, it would have been split into multiple blocks, but the size is only 10 bytes. Okay, so I can only see one block, but I can access this file from any of the machines. Okay, first thing. Second thing is the blocks may be partitioned. I mean, there may be multiple blocks for the same table. One block may be in the hard disk of slave 1, another block may be in hard disk of slave 2. So it is distributed in nature, right? So that is an advantage that you won't get in MySQL or any other database or data warehousing system, right? Which is not working on distributed computing. However, Snowflake, Netezza, they're all distributed. Redshift, they're all distributed data warehousing systems. But again, Hive was the first one. Later on, all these things came. Right? So today's time, Hive may or may not be used. Versions of Hive may be used. For example, in Azure, Azure Databricks. If you're using Azure Databricks, the underlying data warehousing system that comes with Databricks is Delta Table, right? And Delta Table is something, if you go to Delta Table code and see, at the end of the day, it is, the base code is all Hive, okay? On top of that, they have brought in some ACID rules, what you see in other data warehousing systems, right? Like partitioning and all the stuff, right? However, there also you don't have the concept of foreign keys and primary keys. Okay, you can it is without that. But however, like versioning system, maintaining the metadata versions, different metadata versions, all those things are extra that is being built by Delta Table. But at the end of the day, it is built on top of Hive, right? So Hive as a raw, the original Hive data warehouse may not be used. Okay, a version of it may be used in today's time. Even somewhere, if you see Snowflake, there also you will end up seeing Hive. Okay, Redshift on the other hand is built on top of Postgres. That's a different thing, but that is also now, I mean, but they saw what Hive did, and the concept of multiple MPP, multiple parallel processing, right, is taken from Hive. Any data warehousing system today which is using distributed computing is now they've seen what Hive has done, and on top of, so they have tried to mimic it. Okay, so you may be correct. Hive may not be used in today's time, but I'm not going to say it's not. There are a lot of people who are still using the open version of Hive, open version of Hadoop, or they have gone into distributed version of Hadoop and Hive and Spark. Okay. Yeah, I hope that answers your question. And one more thing here, the data will be stored in plain text. I can see it if I download it. Okay, so if you see Praveen and 1. Yeah. So that is something that you won't be able to do it in MySQL. You cannot go to the underlying tables data and read it in plain text. That is another advantage. Okay, so now coming back, let us go back to master and let me start Spark shell, Spark clusters, Spark home / spin start all. Okay, so now let me go back to slave 2, and now here I start the Spark shell. Okay, Spark home / bin by Spark. I'm not going to run it in yarn mode because at this point I have not enabled Hive accessibility to other slave machines. But generally, the Hadoop admin will do that. He'll install it in one machine like slave 2 and make sure that the Hive is available in all the other slave machines, right? So in that case, when you use Pyspark, you can run it in yarn mode, right? So it works in yarn mode. But now I'm using local mode. So if you see here, I've not given master as yarn. I've just given local mode. That means it is only the driver, executor, everything is in this machine itself. The reason is only from this machine, only at this point, I can access Hive. Okay, I do not know how to set it up. I've tried setting it up, but that beeline configuration and Hive, so Hive, we have to do Hive to server configuration. Okay, that configuration is complex. So there are a lot of things that Hadoop admin people do know about it. There are a lot of configuration they do. Right? I don't know about that. So anyway, I am running it in local mode just to show you how we can access Hive. Right. So we do Spark, let's say df1 equal to spark.sql. So this is how I said that you can access Hive tables. At the same time, you can also, if you have saved a data frame as a temporary table, you can access using SQL, right? If you remember, we had saved df1 dot create our temp view, and then from that temp view we had done SQL, right? Same thing we can do Also, we can also directly query the Hive table. I'll directly show you what it is. In the backend, what we have done is this hivesite.xml, right? It was not just placed in Hive conf, but also in Spark configuration as well. So etc/spark/conf. Okay. Config. Okay, let's see what is this. So Spark 2.4, and if you see conf, you see that hivesite.xml same was copied there also. We did that when we were installing itself, so we don't have to do it again. So that is how it knows that Hive is installed here, and that is where I need to pick it up. So if you see, I'm directly able to query Hive table from Spark using Spark SQL. Okay, you don't have to do read.format and all. DataFrame API not required. Just use Spark SQL. You will directly be connected to your machine. Okay, so this is how you connect to Hive from Spark. Okay, and this is where the Spark engine is able to query the Hive table. So that is what the warning was saying. Don't use the default Hive on MapReduce. Try to use either Spark or Tez. Right? Okay, so this is your Hive setting, and this is how you can access it. Yeah. So what is Kafka basically, right? Major use case for Kafka is when you're working with real-time systems. Okay, so real-time system means there is some source that is generating real-time data. Right? For example, Twitter. Right? Somebody on Twitter is writing a tweet every second. Right? So that particular system is generating new records every second. Right? So in such a system, so if we are supposed to consume data from such systems, what are all the tools that can help us? One of the main tool is Kafka. So what does Kafka do is, as soon as the real-time system generates a particular, someone tweeted, right? So a real-time data got generated. As soon as it got generated, it will pass through the Kafka, what do you say? I cannot call it channel. Yeah, I can call it like a channel, right? And it goes to the Kafka server. From Kafka server, it will go to the right consumer. Let's say my cluster, right? The company is Hadoop cluster. There may be another company which has its own Hadoop cluster. So company one, company two, or your own company's two subsidiaries, something like that, right? So there may be multiple consumers trying to consume the same thing, right? So my Kafka is a system that will enable me to transfer the real-time data to the right consumers, okay, as soon as the data is generated. So another example where, so it's called as a messaging queue, right? And Kafka is not the only messaging queue that is available, right? So you can read about 0MQ, okay? You can read about Android messaging queue, Kafka, okay, Kinesis, and so on and so forth. Okay, so this Android messaging queue is already being used heavily on WhatsApp. So what does WhatsApp do, right? So here I have a group. Let's say I have created a group called as Intellipaat. Okay, I write a message, hi, and there are like 100 participants. All the participants, including me, will be able to see this message, hi, correct? So as soon as this message is generated, Intellipaat group has the list of participants, right? So to look at those participants and immediately send all those messages to all the participants, including myself, because I'm also one of the participants, right? So that is how I am able to see the message, right? Because there's a messaging queue which is sending the data to all the participants within WhatsApp, within that particular WhatsApp group, right? And this architecture is called as publisher and subscriber. So why is it called as a publisher subscriber architecture, pub sub, or we can also call it as producer consumer. Okay, so both are same. So what is producer consumer or publisher subscriber architecture, right? So there may be a source which is generating the data. We are going to call it as producer or publisher, right? Then you have a Kafka server, which maintains the list of consumers who have subscribed to a particular topic. So this producer, whenever he sends the data, whenever he generates the data, to that data, he will add something called as a topic name. Okay. So in Kafka server, we have a topic name, and under that, all the consumer information is stored. Okay, who are all the consumers? Right? So as soon as the producer produces the message with attached with the topic number, Kafka server will read the topic name and say, okay, for this Intellipaat topic, these are the consumers, and immediately it will send all the data to the consumers. Consumer 1, consumer 2, and so on and so forth, right? So here, there are certain things that you need to build up, because you may think that, okay, real-time data may be 1 message per second. No, there can be real-time systems where 1,000 messages or 1,000 each message, let's say 1 kilobyte, right? Or let's say 1 MB, right? So 1,000 MB of data may be generated every 1 GB of data is generated every second, right? So we need a system that is fault tolerant to handle all those stuff, the size in the message and also the number of messages, right? So all this is called as message, by the way. All the data that is being generated is called as message. So the system needs to handle n number of messages coming at n number of seconds, right? And the quantity of the message should be able to handle by the system, right? So we need such a fault tolerant system, and that is where Kafka comes into picture. Okay. And it is the one of the pioneers in the messaging system. After that, all those things, Zero MQ, Android MQ, they all came into picture after that. Okay, so Kafka was the first messaging queue, right? So whatever we are reading, I mean, we have gone through in this session, right? Spark Core, Hive, Kafka, they're all the first initial versions of that particular domain, right? Afterwards, there have been a lot of better products, better tools that have created an improvement, right? For example, instead of Kafka, people are using Kinesis, right? Kinesis Firehose, that is an AWS product that is built on top of Kafka, but it is much better, much efficient compared to Kafka, right? Same goes with Hive. I told you there is Delta Table, there is Snowflake, and there are a lot of stuff that I've copied from it. So whatever we have gone through is just the basics of big data. So in today's time, we may see a different version of all these tools, but at the end of the day, the base are always the same. Okay, so if you understand how Kafka works, you'll understand how Kinesis will work. If you understand how Hive works, you'll understand how Snowflake works, right? Okay, coming back. So this is what Kafka does, and we will see how a fault tolerant system is built so that it can handle n number of messages at n number of seconds and be able to transfer those to the respective consumers successfully. Okay, it is one of the messaging queues that exists in big data, right? And outside of big data also, it has a lot of use cases, right? For example, I was talking about Android messaging queue, right? So that is also similar to Kafka. It is also a messaging queue, helps us with moving data from one source to another in a seamless way, right? So basically, these messaging queues are used for real-time systems, right? Where the data is being generated as a pub-sub architecture, publisher, subscriber, or producer consumer architecture, right? So repeat again. So there'll be a producer who is producing real-time messages. We can call it as messages, right? And that message will come attached with some sort of a topic, right? So that goes to the Kafka server, right? And in Kafka server, for each topic, it will maintain a list of consumers. So as soon as a message comes from the producer, it saves it in its hard disk as a partition, okay, and immediately sends it out to all the consumers, okay, consumer 1, consumer 2, consumer 3, and so on and so forth, right? we need Kafka because we may be getting, there'll be a lot of external sources that, from the big data perspective, right? We may have a lot of external sources who may be generating on a real-time scenario. For example, you want to do some sort of sentiment analysis. You're a media company and you want to show in your show that, okay, these many people like Modi, these many people dislike Modi based on the tweets, right? Today's time, nobody goes on the ground and does a survey, right? They all prefer to connect with social media sites and get the data, right? So they connect to Twitter, which is a live source, right? Or a real-time source, right? Where every second somebody is tweeting. There's a guarantee that somebody is tweeting about Modi, whether good or bad. Right? So we have to get the data. We take it using Kafka. So Twitter would be our producer, and the data will come and it will go to our big data cluster, which will be the consumer, and from there we will do some analytics, like, okay, we will do a sentiment analytics. We'll take the data and we'll see whether that person is talking good about Modi or bad about Modi. Based on that, we would create an opinion poll and blah blah blah, right? So that those kind of scenarios exist in big data, right? An actual project that I worked on, FPL, Florida Power and Light. It's a big US electrical generation company, right? So they have, we developed a dashboard for them, right? And one of the dashboard was based on a live data source, and live data source was their electricity generators. Okay, so they had plants and sub plants all over US. Okay, and they wanted to know from each plant how much electricity is being generated. So they have an IoT device attached to the generator, which would send those readouts to the Kafka server, and from Kafka server we would receive it in our cluster. And as soon as we received it, we would check it, because we would have been given a threshold, like it shouldn't be about these many megawatts or whatever it is, right? So if it is above it, we will mark it as red. If it is below it, we will mark it as green in our dashboard, right? So that is the kind of analytics we used to do. So someone who would see the dashboard at any point in time would know, okay, how much each plant is being generating at any given time. Right? So that kind of real-time analytics would require Kafka be part of it, right? So big data alone, all other big data tools alone cannot do it. Okay. So you need Kafka to move the data from external source, a real-time source, to us. Right? But it never started as a big data tool. Right? As I said, it had a lot of scope outside of it. Right? So generally, what happens is, yeah. So in your outside of big data, forget big data for now. In the non-big data scenarios, where you have front-end servers, you have back-end databases, you have log monitoring systems, security systems, data warehouses, right? Those are all your back-end technologies, and in front-end you have some applications like trading apps or net banking apps or whatever. Let's say we are talking from the banking domain perspective, right? So your client may have so many front-end applications, and each of these applications, somewhere they end up connecting with the back-end systems, right? So that is what you see here. Front-end system connects to database, security system, real-time monitoring system, some services, some data warehousing system. Same thing with application 1, application 2, and other chat server, whatever it is, right? They're all connecting to the backend server, right? So tomorrow, let's say the problem here is, you see these many lines, right? Anything goes wrong, let's say data is not moving from here to here or from here to here, troubleshooting them becomes a big headache. Okay. Second thing, from the maintenance aspect, right? Tomorrow I change the password for database server. I have to log into all these servers and I have to change the password, right? Or let's say the IP address itself changes, then I have to log into all the servers. I have to change the IP address, right? So maintenance aspect becomes a problem. Okay. So that is the reason why they started using Kafka even in this scenario as well. So how does Kafka solve the problem? It will, all the front-end data generating sources will become our producers. Okay, and the backend services which consume the data will become the consumer. Okay, as soon as there is any data, let's say front end application 1 has some data, it will send it to the Kafka cluster. Okay, so all the producer needs to know is the information about the Kafka cluster. It is not concerned about the database or the data warehousing system or the real-time monitoring system, whatever it is, right? It should only have the information about Kafka cluster and the topic name, right? So it will send the message, and then that Kafka cluster will look, okay, what is the topic and which is the consumer for that particular topic, and will send the message accordingly, right? So this seamless integration of microservices is the actual use case where Kafka is used in a very big way, right? So here maintenance becomes very easy. I know that if uh, a particular producer is not able to send data to consumer, then I only need to check in the Kafka cluster, right? I don't need to check anywhere else. And next time, if database consumer, let's say database server changes its IP address, I don't need to change anything because the database itself has to connect to the Kafka cluster, right? So I don't need to change producer. I don't need to change anything in the Kafka cluster. Okay, so that is another advantage of using Kafka. But overall, it actually is a messaging queue that is helpful in working with real-time systems with big data systems, right? That's the actual purpose. These are all that is something that came up later, but it is being used in a very big way. So what is Kafka? Kafka is an open source pub/sub messaging system. That's what I told you. Publisher subscriber messaging system or producer consumer messaging system that manages and maintains real-time stream data. Okay. So that is what its original purpose is, right? But as I said, it can be used with non-real-time, non-big data systems as well. Right? It was started in LinkedIn in 2011, and it became an Apache top-level project in 2012. Right? It was written in Java, okay, and just like Spark, it is also fast, it is scalable, durable, and fault tolerant, right? And it is distributed by design. We can also make it distributed as well. Okay, so it has a lot of qualities of what other big data systems do, but as I said, it is not tied down to real-time system. It is not tied down to big data systems. You can use it in our normal systems as well, right? Front-end technology, back-end technology, all the microservices can use Kafka to pass on the data, right? Yeah, so it reduces the complexity of data pipelines. It makes communication between systems simpler and manageable. That's what I said. If tomorrow anything, let's say the backend system IP address changes, you don't have to change anywhere. You just have to make sure that that system connects to the Kafka cluster. Right? With Kafka, it is easier to establish remote communication and send data across the network. Right? We can establish asynchronous communication and send messages with the help of Kafka. So all the messages are asynchronous. So what happens is, once the producer sends the message, it is not bothered whether it reach the consumer or not. So that is what asynchronous communication is. Synchronous communication would be a three-way handshake, right? First, it will send an acknowledgement, and Kafka cluster will return back saying an acknowledgement received. Then it will start sending the data, right? So all those kind of communication doesn't exist. It is completely asynchronous. Reach the Kafka cluster, whether it reach the consumer, it is not bothered about it. So this way, the communication is also faster. Right? Yes, there may be unreliability built in because of the asynchronous communication, but the chances of being ineffective or the message failing to be delivered across is very, very less, point something, right? So we have to take that into consideration before saying that okay, we don't need, we need it to be synchronous, right? Because the failure rate is very less. Fault tolerant is Kafka is a very fault tolerant system, so that what we were talking about, the failures, right? That scenario is highly unlikely, right? So that is why it is asynchronous. Okay. Yeah. So components of Kafka. So Kafka has a broker. So in the previous example, the Kafka cluster, so it has too many jargons. So we can call it as a Kafka cluster, Kafka server, okay, or broker. Okay. So again, this single picture, it's a cluster. It can be a multiple machines forming a cluster, or it can be a single Kafka server. Okay, you can have any sort of configuration. Right? So if you want to build a fault tolerant distributed system, then you need to have multiple Kafka servers form the Kafka cluster, right? Or multiple brokers being part of the Kafka cluster. Okay. So hope you understood what is Kafka cluster, right? So Kafka cluster is collection of Kafka servers or brokers. Okay. So broker and Kafka server, they mean the same thing. Don't get confused. At the same time, we don't need Kafka cluster. We can also work with a single Kafka server itself. Okay. And it will still work, but load balancing and fault tolerance won't be there. If this particular system goes down, then your entire Kafka system goes down, right? So that fault tolerance system is not there. For that, you need to have a Kafka cluster. Yeah. So brokers or Kafka servers that manage and mediate the conversation between two different systems. So it stores the message from the producer and checks what are all the consumers that are there for a particular topic and immediately sends the message to all the consumers. Okay. So message is nothing but your basic data. It will be in byte arrays. Okay. Topics, as I said, each message should have a topic. So in your Kafka server, first thing that you need to do is configure a topic, right? Producers and consumers will then refer to that particular topic and start their communication. Right? Cluster more than one broker, that is set of Kafka servers. As I said, we can either work with a single broker system or a single Kafka server system, or you can have multiple brokers connected with each other, right? And bring in the distributed functionality. So that is called as your cluster. Then you have producers, the actual systems that generate the real-time messages that you need to send across to your remote systems, right? And consumers are the servers or processors that consume this message, and based on that we do some manipulations. Right? Partitions, each topic in the Kafka server will have a partition, right? So let me go back. I have a producer and there is a cluster. I'm going to call it as Kafka cluster, broker 1, broker 2, and then there is a consumer. Okay. And let's say the topic is Modi, right? So Modi is a topic, and in the list we have a list of consumers. We have C1 as a consumer, and for this particular topic within the hard disk of BR1 we'll have partition 0. Okay. And for that particular topic we have partition 1, okay, for Modi. Now what is the advantage is it is load balanced. Okay, so tomorrow let's say we can have multiple producers. One thing is multiple producers writing or sending messages to the same topic, multiple consumers consuming to the same topic. Okay, so all these scenarios are possible, right? So let's say I have LinkedIn, right? And then I have Twitter. So all LinkedIn posts should go to partition 0. All Twitter posts should go to partition 1. So in this way, I'm load balancing it, right? And I can make sure that the data. I mean, there is no waiting period, network overhead, right? So that is another advantage of partitioning. Second thing is, fault tolerant systems can be built in, right? Just like in HDFS. Do you remember how HDFS is fault tolerant? There is a replication factor. There's a replica of the partition, right? So we will make sure that the replica of partition 0 exists here, and replica of partition 1 exists here, right? Replica of partition 1 exists here. So in case this broker goes down, all the messages would periodically will be synced with all the partition messages would be synced here, right? And this would become the new leader. So now the this producer can start sending to broker 1, right? So this way we are also making it a fault tolerant system, right? Load balanced fault tolerant system, right? At the same time, it is highly scalable. I can keep adding, I can get another server, configure Kafka on it, and I can add it to the cluster. So I can keep horizontally scaling it. There's no issue with scalability, right? So that is another advantage with having a Kafka cluster rather than a single broker setup, right? Single broker setup, I may run out of hard disk, right? Because, or I may, the network may be busy, right? So, or if this particular broker goes down, the entire system goes down, right? So that is a disadvantage with single broker system. Okay. So generally you'll be working with a Kafka cluster. So now we will install the Kafka server on our cluster. And then I'll show you an example. Yeah. So let me first do system CTL start IP tables. Stop IP tables. So that's one. Set slave 2. Okay, so last time we have downloaded the Kafka and Flume zip files, right? And we were able to extract it to /etc/Kafka. And if I'm not wrong, we have also copied the configuration files also. Let me go to conf cd config yes, let me see cat server.properties. Zookeeper is this, okay. Okay, we need to uncomment this in one of them, okay. So first we need to decide which among the three I would want to make it as a Kafka broker, right? So I will make slave one as the Kafka broker, and master and slave two can be producers and consumers, right? So let me go to slave one. So whichever machine I decide to make the broker, in that machine I need to go to slave Kafka and then config, and then vi server.properties. So here if you go, there is this listeners equal to plain text colon 9092, right? It is commented. Make it uncomment it by clicking on the I key. So it is an insert position, right? And then click on escape colon WQ, right quit. Okay, and let me see zookeeper properties. Let's see, I set up, sorry, Kafka setup. Okay. Client port 2181, okay. Next client is 0, nothing else here, okay. So no, nothing required. Okay, transaction. First thing is Zookeeper. So Zookeeper is a server that manages the Kafka brokers. So I may have 10, 20 brokers, right? But I need to manage them. There has to be a a tool or a server that would manage these servers, right? So Zookeeper is the server of servers, right? So it will make sure that all the brokers are up and running. It will make sure that, okay, if broker one falls down, then it has the information of all the topics and partitions, right? And where the replicated partitions are. So then it will go and say, okay, broker two, you have Modi topics partition 0 replicated 1. The original partition has fallen down. Now you are the leader for partition 1 as well, right? So all those kind of work is done by Zookeeper, right? And it comes inbuilt when we download Kafka, right? So first thing is we need to start Kafka server. Okay. Before that, I need to have a couple of sessions as well. Duplicate session, root, slave one, servers. Start.sh. Oh yeah, I need to give the Zookeeper properties Kafka home /config /Zookeeper properties. No such file or directory /etc. Storage. So, config. I think the installation was not proper. Let me check with my other machine. Root and cd dollar config unless I don't have Kafka run here. Which version did I install? Um, my laptop froze, I guess. Let me Kafka 2.11 2.1.0. Let me see what version I have. Kafka 2.11 2.1.0 tzip. It's the same file. What am I doing wrong? So keep the server start.sh. Zookeeper server start.sh. Okay. Let me go back. $home. Zookeeper server.sh. Okay, I shouldn't have done sh, so it's working. Okay. So this particular thing has to be running. Okay, this terminal has to be running 24/7, or else your Kafka won't work, right? So that's why I have multiple terminals for slave one. Now Zookeeper has started. Next thing is I need to start Kafka. Okay, Kafka server start.sh, Kafka home config server dot properties. Okay, so there are no errors. I just need to check that. Everything is info. Okay. Info. Okay, so both server, Kafka server and Zookeeper has started. Now let me have, I'll make master as my producer and I'll have slave 2 as my consumer. Okay. Let's slave 2. Slave 2 is my consumer and master is my producer. Okay. So one thing about Kafka is you don't need to have any programming knowledge, right? You can use their own console producer script and console consumer script to be able to send messages across. So if you know shell scripting, you can still work with Kafka, right? That is one other advantage. But we can also use it in Python. We can also use it in Java. We have libraries in Python. We have Kafka Python in Java. I think it is org.apache.kafka. Okay. Same thing with Scala as well. Right? So we can use programming language as well. For now, I will show you how to do using the shell scripts that are available within the Kafka. Right. First thing, before starting anything, we need to create a topic. Right. So command to create a topic is Kafka topics.sh. So while giving Kafka topic, if you see, we have all the information about where is the Zookeeper server, what is the replication factor, how many number of partitions, and then finally the name of the topic. Right? So this should answer some of the questions that we discussed. Right. So let me just copy paste this. I can call this shell script in any one of them. Oh, sorry. I can call it in any one of the servers and it should still work. Kafka topics. But Zookeeper server start and Kafka server start should happen in the same machine where I'm decided to make those changes, the server properties and Zookeeper properties. So only in that machine only I need to start Zookeeper server and Kafka server. But however, topics and other shell script I can run it anywhere else. Okay. Zookeeper, it is not localhost, it is slave 1 $2181. I'm going to make replication factor 1 because I have only one broker. I don't want multiple copies to exist in the same broker. Right? Partitions, I can make 2. Topic Modi. Command include exactly one action list. Create, sorry, I forgot to give create somewhere. It is, yeah, first thing I need to do is create. Okay, so it says the topic Modi got created. In case I want to see all the topics within my cluster, I can give the list command. What happened? So I'll give it from slave 2. Okay. Let me. So if I want to say list all the topics within the Kafka cluster, instead of create, I need to give list and then I need to give the Zookeeper information. Okay. Yeah, so if you see, it is giving me Modi, right? So I have only one topic, right? Again, you need to see here that Kafka topic shell script, we give Zookeeper information and not the broker information. So that is where exactly the topic is stored, right? Topic information. However, later it is propagated to all the brokers from the Zookeeper. So now coming back, next step is to start the consumer and producer shell script. Okay, Kafka console producer such. I think it is broker server broker. Forgot the commands. Broker list. Yes. Broker list. I need to give slave 1. But here I'm giving the Kafka port number, not the Zookeeper port number. Zookeeper port number was 2181, but Kafka was 9092. If you remember, I had uncommented that in server.properties, right? So slave 1 and topic is Modi, and I can write it to partition 0. Okay. Partitions or partition, let us see.
Let's have a quick quiz question, guys, and the question is, profilers in Pyspark are, and your options are, useful for building predictive models, helpful in data cleaning, useful in batch processing, or none of the above. Please mention your answers in the comment section below.
So first we'll do without writing it into any partition. I won't decide at the producer level. Okay. Okay. So now I got a greater than sign. That means the console has opened. I'll go to slave 2. I will start Kafka consumer console consumer.sh. Here it is bootstrap server. And instead of, so we call it as bootstrap server on the consumer side. It is still the same thing, broker information only. So bootstrap server slave 1 and then topic Modi, and I'm going to say read from all partitions. So from beginning, option not recognized, BEGINNING, spelling mistake. Okay, so now I will send hi message 1. So if you see, immediately the consumer was able to consume it, right? So hi message 2 is able to consume it, right? So now here this is a scenario where there is no partition information given, even though I created 2 partitions for a particular topic, right? Modi, I created 2 partitions if you remember. I think I created it in masters. Yeah. So if you see here, I created 2 partitions, right? So there is partition 0 and partition 1. Right? I can read from a single partition also. So let's do that. Right? Let me exit JPS and check. Okay, nothing is running. And here I can give partition information. Partitions 0. Okay. Just making sure that partition, okay. Partition 0. So if you see, only message 1 was in partition 0. Message 2 is in partition 1. Okay, so now if I do hi message 3, I won't get it because that is in partition 1. Message 3 I got it. Hi message 4. Let's do message 4. Hi message 5. Hi message 6. Hi message 7. So now if you see, half the messages came, half the messages did not come, right? 1 came, 2 did not come, 3 came, 4 did not come, 5 came, 6 did not come, right? Because they were part of partition 1, right? So that's what I can do the setup on the consumer side, from which partition, specific partition I can read. I can also give offset number, right? So each message has an offset number. So you send the data to Kafka, right? Producer sends data to broker, right? So that message within that particular partition gets stored in offset numbers. Okay, it will start from 0, 1, 2, right? First message will be stored here, next here, next here, next here, right? So that is why I have given from beginning, right? Because I don't know the exact partition, I mean offset number, right? So I just said from beginning. So you give me all the messages for partition 0 from beginning. However, I can change that also. JPS. Instead of from beginning, I will do offset equal to, I will say from offset number 2. Okay. Offset a single word. Yeah. So from offset to, it is message 5 and message 7, right? So these kind of settings I can do on either side, right? I mean, I can do this part of setting. I have to do it on the consumer side itself, like what partition I want to read and from what offset number. However, while writing, if you see, I did not give any specific instruction that I'm going to write this to partition 0 or partition 1. However, I can do that in producer also. But here in this scenario, Kafka broker itself took that decision that this particular message should be in partition 0. This will be in partition 1. This is in partition 0. This is in partition 1. Right? So now let me show you how we can do write it to particular partition. Partition 1. Yeah. Partitions. Put this. Partitions. Had an option, okay. At least in while we are coding using Python or something, we do have an option. Even in here also I have. I just don't remember the name. Okay. What's that? I think. Help is also not there. Okay. So now I have retry backend sync. Okay. Looks like for the shell script is not available. Okay. But within my Kafka, this one, what do you say, library, if I choose not to go with the no, so in that it is possible to send a particular message to a particular partition. I don't know why it is not here. I think in the later version it is there. We have downloaded a pretty not outdated but an older version, right? So it may not work, but yeah, that's what. But we can do that. Okay. Property user config. No, what is the property? No, send. Bytes, line reader, compression code, broker list. Okay. Yeah. Okay. So we can't do that using the what do you say? The producer. But on the consumer side, we are able to read from a particular partition itself and from a particular offset, right? So that we are able to do it using the shell script itself. In a single broker system, all the partitions will exist in the same broker. But in a multi-broker system, there's a chance that for a particular topic, the given partition may be sitting in a different broker, right? And as I said, each producer can write to it to a specific, write messages to a specific partition if he wants to, right? But unfortunately, the shell script doesn't have it. The latest version has it. Okay, I remember using it. So the latest version of Kafka does have it in the shell script itself, but unfortunately, the older versions don't have it. But however, PyKafka has it, the Python library. So when we are doing, when we are using Kafka using the Kafka producer consumer program in Python, we can do it. Okay. Can show you. Value serializers, compression type, retypes, class size, in the partition available. You should determine which partition. If you see here, while using the Kafka Python library, we can give. Okay. So for a producer also, we can mention which particular message saying used to determine which partition each message is assigned to. Right? So we can do that using Python. But yeah, the older version of Kafka shell script, it is not available. Okay, coming back. So yeah, in a single broker setup for each topic, all the partitions are in the same machine. But in multi-broker system, there's a chance that for each topic, the partitions may be in different machines, right? Diagram now. So what happens? Producer A writes to a particular partition, he or she wishes so. If that particular setup is not done on the producer side, broker itself will decide which partition it should go to. Right? If it decides that it should go to partition 0, then it will put it to the latest offset. Right? So it will start from 0 offset. Right? Next message will come in 1 offset. Next message will come in 2 offset, and so on and so forth. Right? Again, from the consumer side, in the consumer side, you can make settings such a way that you only read whatever is there in partition 1 or partition 0, right? So whenever a message comes to that particular partition, immediately that message will flow on to consumer automatically, right? If you are reading from partition 2 and any new message comes to partition 2, that particular message will immediately go to that particular consumer, right? So like that, we can have different consumers reading from different partitions.
Just a quick info, guys. Intellipaat has a data engineering course in association with MIT MicroMasters and is designed by top domain experts to help you master core data engineering skills like Python, SQL, AWS, Spark, Kafka, and etc. Learn from top faculty at MIT and get certified. Enroll today.